Hello and welcome. Hi, I'm Dave, and today we're going to build a full-featured weather app with Vanilla Javascript. And if you've completed my 8-hour JavaScript full course tutorial video, this is a great project for pulling all of those concepts together in one application. I explain everything in detail as I go, and I've also added bookmarks in the description below so you'll know where each section starts and ends. This weather application includes a foundation of Semantic HTML, a responsive mobile-first web design, CSS compiled from SCSS, also known as SAS, or Super Awesome Style Sheets, Vanilla JavaScript, accessibility considerations throughout, persistent data, the Fetch API with Async Await, and serverless functions. Is this app perfect? Not at all. And I'm sure I'll want to refactor some of it after I step away from the project for a while. At the end of the tutorial, I'm going to discuss improvements and future challenges that I think you may want to tackle after you complete the steps that I show you today. So let's get started. Okay, we have Visual Studio Code open and we're ready to start building the foundation for our site. You can see I have a folder named Weather App Tut for Weather App Tutorial. And inside this folder, instead of creating an index.html file right away, I'm going to create a folder and name this folder dist, which is short for distribution. And we're actually going to put our HTML inside of this because we will end up hosting our application on Netlify, and we will use the dist folder as the build folder, even though there won't be really anything for this application that is in a build process, I guess is the word I'm looking for. But at the same time, we're going to use serverless functions, so we're going to structure our app in that way, as you would with possibly a React app that would actually have a build command. So, or if you used Webpack, actually you could with Vanilla.js. We're not going to get that complicated, but we'll create our indexed HTML file inside this dist folder. And from here, this will look more as you're used to seeing things. I'll hide the file tree for now. Type an exclamation mark to start this IMIT abbreviation and get the skeleton for our page. And for the document title, I'm just going to type responsive weather app. And after that, we need to break down this app as we look at it. We've really got 4 separate components that could be ordered in any way we wanted to. We've got the top search area. And then we've got the big area here that is the current forecast, the current weather conditions. Then we've got the 5-button area towards the bottom, but not at the very bottom. And this is really the nav area of the site where you can do 5 different things. So it's really navigation through a single page application, which is what this is, a spa, if you will. And then at the bottom, the 4th component is the 6-day forecast that comes out here in advance, the daily forecast throughout the week. So we can break it down into these 4 sections, and by doing so, and I just said section, we're going to use semantic HTML elements to label or contain each one of these sections. But the main container, the body will span the full page no matter how large the page gets. The main container will be the main element, which again is a semantic element. And then inside this main container, we will have our 4 sections. But as I mentioned, one is a nav area, and there is a separate nav element that you can use specifically for that as well. So let's go ahead and start adding these details now. So inside the main area, we'll have a section, and I'm going to give this a class equal to search bar, and that is the first section. The next section is the current forecast. So we'll have another section element, again, semantic elements here. And I didn't give this an ID of search bar, but let's go ahead and do that. It's a good habit to do both, just in case we would need it. So you get the class and the ID of search bar. Let's do the same thing here with an ID equal to current conditions, and then a class that's also, actually I said conditions, let's call it current forecast. I like that a little bit better. Current forecast, and we'll call the class current forecast as well. And that section closed out, and we can go ahead and minimize this and make this larger just so we can see everything for now. and that quote would cause a problem later that we wouldn't expect. After that, we've got a nav area now, and we're going to call this nav. We'll give it an ID of nav buttons because that's really what makes up the whole area, our 5 buttons. And there's the nav area. And after that, we've got our daily forecast area. So one more section. We'll give this an ID of daily forecast, which differentiates it from the current forecast. And then a class also of daily forecast. And that finishes off that section as well. Now we will fill these sections dynamically, but there is some more to add before we even do that dynamically. And there's a little bit to add outside of the sections that we'll use for some navigation for accessibility concerns. And the first one is just putting an H1 header on the page. And we'll go ahead and put responsive, there we go, responsive weather app powered by the open weather. And now I'm going to say API, but I'm putting spaces. And this is specifically for a screen reader. So I know the screen reader will read API. And this is for accessibility reasons, because in the end, we will not even show this on the page. We will give it a style that takes it off the page, but screen readers will still read this. And so there's our header, and it kind of identifies the entire page. But now in the search bar section, let's go ahead and add some more information here that will not be dynamically generated. And it's a complete form. If we look back at our application, this search box right here, this is all a form where we can submit city, state, country, or a zip code and get the weather back for that. So once we do that, we need a form that will actually submit that information. So we'll start with form. We'll give it an ID of search bar, 2 underscores, and the word form. And this is a BEM, or block element modifier, naming convention. I tend to use it a little bit loosely, but at least it helps organize each section. And when you look at the styles, you know what you're referring to back in your design. So I'll give it the same class. And now we're also going to give this a role, and this role is search. And once again, this goes back to accessibility, and a screen reader will read and get to the form, and it will know what this is about. And so we give it the role of search, and now we need a label. Once again, even if we don't show this label on the page, it is important to have a label for every input in a form. So here we'll say search bar, once again with the BEM naming convention, and then text. So this will be for the input in the form. And then the class, we don't need to give it that same class, but let's just say enter a new location. And we've got the label, and that pretty much wraps that up. Now we'll put the input that goes with the label. And the ID here will be search bar underscore text. And you need these two to match. When you have a label, you need it to match. The for attribute needs to match the ID of the input that the label is for. So here we once again have search bar text. And now we give this the class of search bar text. The type equals text. And the role, which goes along with, we had a role up here for the form of search. Now the input, we gave it a type of text, but we'll give it a specific role here of search box. And so we know that this is a search text input. And going along with that, actually, you could, and I will discuss this quickly, you could give it a type of search instead of type of text. But I have also found that that is a little inconsistent between browsers. Text has been around a long time, and it's just much easier to control. So I prefer to use type text in a role of search box rather than just saying type equals search. Okay, we're not quite finished with the attributes here. So let's continue to add the rest. We have size, and I'm going to limit that to 40 characters, which should be enough. Autocomplete is going to equal off. And let me go ahead and press Alt-Z to wrap this text as it's getting pretty long. Okay, after autocomplete, we'll put a placeholder attribute. And this placeholder attribute is going to hold the short version that says city, state, or country. Now we will look programmatically with JavaScript to see how wide the page is later. And if it's wider, we'll go ahead and put more detail in there where it says city, state, country, or zip, as we saw in our example here. It says city, state, country, or zip code. But if it's the smallest size of phone, it's just going to say city, state, or country. And before we're finished with our form, we need to add a button. So right underneath the input, we'll type a button element, and we'll call this search bar, 2 underscores, and button. I can spell button right. We'll give it the same class, search bar, 2 underscores, button. And we'll give it a title equal to submit location. And we'll give this an ARIA label, which is for accessibility. And this is what a screen reader would read for the button. And we'll put enter zip code or city, state, and country to retrieve weather conditions. And you can see how this is an alternate to what the button might say for the person that is just viewing the button. And it's a little more direct. We're just providing a statement saying exactly what this button does. And so that's a good label for it. Now here we'll just type submit to show on the button for now, but we are going to replace that with icons. So now that we've completed our first section, and this is our search area section, let's go ahead and bring the browser back, and we can see this is the search area section here. But I'm going to use the live server extension, at least on the first part of this application as we design the HTML and the CSS or SCSS styles. So go to your extensions icon in Visual Studio Code if you don't already have live server, and here you can search for live server, and it's by Ritwick Day. You click that and you can go ahead and install live server. You see I've already got it installed. And from there, back in the HTML, you can right click and choose open with live server, which is what we'll do. And we'll start to at least get a view of the HTML we have created so far. And it doesn't look like much, but this is what we currently have. Okay, before we go any further, let's go ahead and get the other resources we need for our page. I'm going to expand the browser for now. And the first site we want to go to is cdnjs.com. And here you'll search for Font Awesome. And you can see I don't even have to type it all. And I've got Font Awesome here. And we can just copy the URL or copy the link tag. And let's go ahead and just copy that link tag. And then we can put it into our code over here. And let's go ahead and just put it right under the title. And you can see it's a link to a style sheet, and it links to the Font Awesome library. So now we can use those icons in our code. But that's not the only resource we need. We also need to get something from Google Fonts. And here at the fonts.google.com page, I'm going to search for Montserrat. And here it is available. So I'll click on Montserrat. And we want just the regular Montserrat. So here's regular 400. I think that's what we'll go with. And you can click select this style. And then it gives you link or even at import instructions for CSS. We're going to go with the link here. So we'll just copy both of these. And then note that it says font family and then Montserrat, and as a fallback use sans serif. So we need to remember this part when we get back to our style sheet and we're declaring the font family. But for now we're copying these two links, and we'll go back to our code, and underneath where we brought in Font Awesome, I'll paste both of those links. I'll tab that over to make it fit right, and we'll go ahead and save the page. And now we have brought in Font Awesome and the Google font Montserrat. Now note back here, I'll expand the browser one more time. For Font Awesome, when we search for icons, you go to fontawesome.com/icons and you can get the details. So for example, if I type in search, it brings up search icons like this one here. And when you click on that icon, it takes just a second to load it. Then you can click and copy the HTML for the icon element and the classes that it also needs. I've already done that, so I won't walk you through doing each one of those for our page, but I wanted to let you know how you could search for some. Maybe you want to change those out or find your own to use as well. All right, let's go back to the code and we'll start to enter those icons. Let's scroll down to where our search button was. And so now instead of the word submit, we'll start with the icon element. And just fun fact here, this I element used to stand for italic before we used CSS in HTML, and you would use this element to make italic text, but now it is commonly used for icons. So we have I, and then we'll give it the classes that Font Awesome said we need to use. So we'll use FA and then FA-search. And once we close that out, we get the closing icon element tag. And we want one more here, and this is because we're going to hide and show these, but you can animate Font Awesome elements, and this is FAS and then FA-sync, and then we'll put also FA-spin. Now I won't put in the class to hide it yet, so right now we'll see both of these, but this should actually spin because they do have a built-in animation that you can apply to any element, and that is an FA-spin class. So this is the sync icon, and then this class is actually what will animate it with the FA-spin. So when we look at our HTML now, we'll probably have two icons there because we're not hiding anything yet. So let's bring this back, and I'll drag this down to the full size. And we'll go ahead and do the same for our browser. And we'll look at the responsive. And there we have the animated sync icon from Font Awesome. And here we have our search icon. Now we'll only show one at a time. We'll do that with our CSS that we apply. Let's go back to the HTML. I'll hide the file tree once again to give us a little more room. And I'll also expand the window. Now we finished our first section. In Visual Studio Code, over here by line 16, you can collapse the HTML sections now, and that's what I'll do. So I've collapsed that, and let's look at our current forecast section. But before we put anything in this section, which I can go ahead and add the line break at least, there's something we will put before the section, just like we did with the H1 before the first section. However, this is a skip link, and what this does is helps anyone with a screen reader skip from section to section without actually having to navigate through that section and all the text within it. So here we're going to identify our current forecast, and then we'll also put in a class and put that equal to skip link, which we'll define this class later. And then we'll make the link say skip to current conditions. And once again, this will not be visible all the time, but when you tab through the page, it will become visible when it has focus. And this will let someone skip directly from the search bar section when they tab straight to the forecast, and we'll put in one later, of course, to go to the 6-day forecast as well. So let's go ahead and save that, and now we'll go ahead and add some information inside the current forecast section. Actually, before putting information in the current forecast section, there's a couple of things, or a couple of attributes we want to add to this section that will also help with accessibility. One, we'll give this a role equal to region, and the other is we'll give it an aria labeled by, which will define the label. If I could spell labeled by, there it is. And let's set this equal to weather location. Oh, and then it tried to add on an extra section by default, or closing section by default, and we don't need that. We've already got our closing section. And now inside this section, let's add an H2 element. And here we'll say ID equals current forecast. and then 2 underscores and location. And let's give this a class as well, so we won't end that yet. And class, oh, that's why I'm seeing the white there. It closed the H2, or I closed the H2 by mistake. Okay, class is going to equal current forecast, 2 underscores and location also. There we can close out that H2 now. And here we'll say current conditions, and that is the subtitle for this section on the page. And we can also then include a div that will be populated dynamically, and this div will have the current forecast in it, or the current conditions, as we referred to it in the title as well over here. So I guess I wasn't consistent when I said current forecast in the labeling, and then we're telling the user current conditions, but that's what I'm doing. You can relabel it if you want to. I'm not going to go back and change that at this point. So we've got current forecast, 2 underscores and conditions. I'll give it this class as well. Current forecast, 2 underscores and conditions. And we close out the div. Now this is the div that will be dynamically populated with that current forecast. So we finished this second section that has the current forecast, or the current conditions, if you will, inside of it. Now, as we did before, let's go ahead here on line 27 and we'll collapse this section. And let's move on to the nav section. And before the nav section, just like before the forecast section, we'll copy this skip link. And I'm going to add another skip link here. And this is very similar. We'll just have this go to the daily forecast, which is the 6-day forecast. And then we give it a class of skip link as well. And we can say skip to, and I'll be specific here, I'll say 6-day forecast, which is the 6-day forecast that we'll see at the bottom of the app. And that will allow users to just skip over this navigation area and not have to tab through each section and go straight to that 6-day forecast. Okay, during or inside the navigation section now, we want to add all of these buttons. So we have a class of nav buttons and an ID of nav buttons. And here we will add all of the button elements. And of course, we'll have icons from Font Awesome inside. So the first button that we have will have an ID equal to get location. And this will get the latitude and longitude and the weather for the latitude and longitude that the user is currently at. And we'll give it a class of button that we'll define later. And for the title, we'll say get location. So in a desktop version, when you mouse over the button, the title is what we'll be seeing. We'll have an ARIA label that again can be more specific, and we'll say get the current weather conditions for your current location. And now we'll stop that. Now inside the button, we'll have the icons again. So we have our normal icon that will be seen. We'll start with FAS and then FA-map-marker-alt. And that is the first icon. The next one is the same thing we had above. So let's expand the first area, that form where we did the search. And we once again want the sync that has the spin. That is the one that looks good animated, in my opinion. So we can collapse this after copying it, and we can just paste that same button in right there, or the same icon, not button, and that will be animated. So if we save this and look back at our page, now we've got the animated icon here as well, and you can see that alt map marker that we defined right here as well. So it looks a lot like you would see on Google Maps, and that's the first button icon we want. Let's go ahead and expand this again, and let's add the other buttons. And I think we can save a little time by copying and pasting each one, and then going ahead and just what's the word here? Changing. Let's just go with the word changing. I cannot think of the other word I was thinking. So this will be home. It will be a home button. Still got the class of button. The title will be home weather. And of course, we want to be more specific here. So we'll say get the current weather conditions for your home location. That looks good. And then instead of the map marker alt, we'll have FA-home. And we should get a home icon there. The other one, this animated one, is just the same, and it will be the same for each one. Let's go ahead and copy that button, paste below, and now this will be the Save Location button. Once again, a class of button, and instead of home weather, it should say Save Location. And now we'll say Save the current location. Save the current location as your home location. There we go. And now instead of FA home, we want FA-save. Everything else is the same there. Copying this button once again for our fourth button. And this will be a button that toggles the units from Fahrenheit to Celsius. So metric or imperial measurement units actually. And we'll just call this button, or give it a ID of unit. It still has a class of button, and the title will be toggle measurement units, and the ARIA label will be toggle between metric and imperial. So this is going to be totally different. Toggle between metric and imperial measurement units. And the icon we want here is a chart bar. You may find a different one that looked like a measurement icon to me, so that's what I went with. And we'll copy the button one more time for the fifth and final button, and this will be a refresh button. So instead of unit, we'll call this refresh for the ID, and then we'll still have button. The title will be refresh weather. And the ARIA label, refresh the current weather conditions. Current weather conditions. And then for the refresh icon that we have here, it will be FA-sync-alt, which is the same or almost the same icon as FA-sync. Let's save this and once again go back and look at what we've got. Now we've got all of our icons and what they will switch to when they're animated. And you can see this FA-sync-alt looks almost like the animated one here, and that's the refresh icon. Okay, just a little more HTML to add, but not much. So we'll come down to the last section. Just above this last section, let's add a horizontal rule right here. And that's just the line that we see across the app. And I can go back actually and look at that app to point it out. It's the line that we see right across here above the 6-day forecast. And after that horizontal rule we've added, which has been an element that's been around for a long time, let's add some more information inside the section ID that has the daily forecast. Oh, we also need to add those same attributes here. So that we added, let me go ahead and hide the nav area or collapse the nav area. Right here, the role region and ARIA labeled by attributes that we added to the current forecast section, we also need to add to the daily forecast section. Now they won't be labeled by the same thing, so we'll need to change that. It'll actually be labeled by the daily forecast title. And now we can add that information here in the section. This starts with an H2 as the subtitle, and the ID will be the daily forecast title, so we can pick that out. And we'll give the class equal to the same thing, so daily forecast 2 underscores and title. And then we'll give the actual text to be read as 6-day forecast. And that's the end of the H2. And now we'll add once again a div that will have that dynamic content in it. I spelled div correctly, and have ID equal to daily forecast 2 underscores and contents. And this is what will be populated dynamically with JavaScript. Set the class equal to the same thing, to daily forecast 2 underscore and contents. And so we don't put anything inside this div. And that's the end of the section. Now we've got one more thing to add just underneath the section. This is a paragraph element. I'll give it an ID of confirmation. I'm going to give it a class of offscreen that will also come back and add to a few other elements when I define that class. But I want to go ahead and add it to this one now, an ARIA live attribute. And we'll set that equal to assertive, meaning it will make these announcements right away. And this will also be populated dynamically. But what this will do is it will make announcements to a screen reader that we send to this area. When we populate it dynamically, it will automatically read those. So we will end up positioning this off screen, as you might be able to tell by the class. But when we search for something or get certain results, we can actually send a statement to this paragraph element and it will be read by a screen reader. So let's save that. Now before we say we're completely finished with the HTML, I noticed one small error I have. I think I had an old label in here when I said this is ARIA labeled by weather location in the current forecast area, because it's actually, once I applied the block element modifier BEM naming convention, it's labeled by the current forecast 2 underscores and location. So that's what we want to put here instead of weather location, and save that. And now the HTML is complete except for a few classes we will come back and add as we apply the styles. Okay, it's time to start applying styles to our HTML. I'm going to collapse each one of these sections that we haven't. So there's our daily forecast section that's collapsed. We have our search bar collapsed, and now we can collapse the current forecast. But we have each one of our sections identified for the app. I'm going to go ahead and pull this back over to the left so we can see both things at once again. And here's the HTML we have. Once again, it doesn't look like much. The 6-day forecast will be populated dynamically, and so will the current conditions. And here's our nav area. We can see our skip links that won't really be there later on. And also we can see our H1 that won't be there. Or when I say won't be there, won't be visible on the page. They will be there for screen readers. But this is the basic HTML before anything is populated dynamically. Let's go ahead and show the file tree once again. And now outside of the dist folder, so in the main root area, I'm going to create a folder called SCSS. That is a style of Sass, as you see the Sass logo here. So there's also SASS, but the most commonly used one, the one I'm familiar with as well, is SCSS, means super awesome style sheets. And that's what we're going to do, and it will compile to CSS, and I'll have mine minified as well. So to do this, the first thing you want to do is go back to the Visual Studio Code extensions icon, search here, and not live server, but search for live Sass. And you should see live Sass compiler come up. Now this has Ritwick Day. This is the older one, and this will work for what I'm going to do. And it supports the @imports, which is what I will use, and I'll discuss that in a moment. But there's also the newer version, and it's down here for some reason, Live Sass Compiler by Glenn Marks. It is currently being updated, where the older version by Ritwick Day is no longer updated. So I suggest installing Live Sass Compiler by Glenn Marks, and it is currently up to date, and it is also applying things like @use and @forward, where the older version is not. Now today I'm going to go ahead and do this the old way of @import, because I didn't want this to be a tutorial where I'm teaching the new way of using @use and @forward, even though they've been around for a while, and if you're familiar with those, you can go ahead. I'm just not going to do that today. The first thing I'm going to create inside this folder is a main.scss file. And this is where we will pull in all of our partials. And so really all this will do is pull everything else together. And these partials will have the different styles, the definitions for our app. One other thing I should show you though, before you know where this compiles the CSS to. We need it inside the dist folder. We want it to create our CSS folder inside the dist folder and then our CSS in a minified file. Let me show you how to do that. Go to File in Visual Studio Code, Preferences, and then Settings. Here you can search for Live Sass, and then just any of this that comes up. When you see Edit in settings.json, click that. And now that we're here, if I could get that to stop mousing over and showing other things, you go ahead and expand that so you can see it well. Scroll up just a little bit, and here's what we're really looking for: live sasscompile.settings.formats. The format I have is compressed. That means we'll have a minified file when it's finished, and then we'll end that file extension in .min.css. And because we named our SCSS file main, our CSS file will be named main. So it will be main.min.css. And the save path is in the dist folder and then in a CSS folder. And it will create that once we click Watch Sass down here in the bottom. So make sure you have those settings. Save the settings.json file if you make changes. You can close out of that, and I will close out of my settings. And then once we start watching the Sass, this will compile and create those files. So I'll show you that in a second, but first let's go ahead and map out our SCSS file structure. And I'm going to use something they call the 7-to-1 architecture, although I'm only going to have 5 folders. I'm going to leave out the pages folder because this is a single page application. I'm also going to leave out the vendors folder, and that's because I'm not really pulling in anything else from third parties other than what we already linked to in the index.html, which was Font Awesome and Google Fonts. The other 5 folders that you see commonly in that 7-to-1 architecture are, I need to be inside the Sass, so I'm going to highlight this SCSS folder, create a new folder called Abstracts. And then once again, I'll highlight that SCSS folder, create another one called Base. And now I'll create one called Components. And now I'll create one more called Layout. And finally, the last one I create will be called Themes. And then we'll go over these as we create each file. First, we'll start creating files in the abstracts. So I'll click New File, and as an abstract file, I need to click New File again. I clicked away for a second. There we go. As an abstract file, I'll start _ colors.scss. Now, this is good to know also. Every partial needs to start with an underscore. When you import partials, you don't have to have the underscore there. If you do have the underscore when you import, it won't hurt anything, but they don't have to be there. But here is the colors partial. And now I'm going to paste in my colors so you don't get bored seeing me define all these different color variables. And you can, of course, pause the video and copy these if you want to as well. So here are the different variables with colors that I'm defining. I've got a font color, a background color. You can see now I have some colors based on what the weather is that we will dynamically change later. It's like fog color and night color. I've got a mask color, and you'll see how that works. A button color, so it's transparent. Border color, container color, a button text color, a shadow color, a text shadow color, and then even a fade color. And these are all variables that we define that we can use later on in the styles. So we need to import that. So now if we go back to our main CSS file, we can use an import statement and type @import and then put abstracts/colors. And you can see Visual Studio Code wants to provide colors with the underscore, but once again, since the underscore is not necessary, you also don't need the extension afterwards. Abstract/colors works, and you can save that. Now let's go ahead and click that Watch Sass, and you should see the folder created over here in the dist folder. And yes, after I click that, the output here, and it says it's watching. If I drag this up, there you go, watching. So it's looking for changes, and it saves as soon as we save changes. It instantly created the CSS folder, and inside the CSS folder it created the main.min.css. It also created a .map file that you don't really need, but I haven't told it not to create that. You could probably find that in the servings, in the settings, not the servings, if you do want to change that. So there, it's going to now create that file that we need. So now that we have that back in our HTML, we need to link to that as well. So we'll create a link tag and add a rel attribute that says style sheet. And then the href is going to point to CSS and then our main.min.css. And save that so the style sheet begins to apply to our HTML. Okay, now we've created our colors partial that's in the abstracts folder, and we've linked to it in the main SCSS file, and then it all compiles to CSS. Let's go ahead and create our next abstract file, and this one is going to be called mixins. It starts with an underscore and then mixins.scss. Mixin definitions in SCSS or SAS allow us to save time later on when we include them, but we just have to define them once at the beginning and then just include them later. So for example, this flex center mixin that I'm going to define, I have to type three definitions here: display of flex, justify content of center, and then align items center, just to center something in a flex box. And now later on, I'll just have to say include flex center instead of typing these three definitions every time. So that is the joy of using a mixin. And we can also do that with a media query. We can pass in a size variable. And now this is the only time that I'm going to have to type out at media only screen and min width, and then we'll use that size variable. And then in here we can just say at content, and we save that. Now later on, we'll just be able to use this media query without having to type all of these other things, and you'll see how I do that as well. I'm going to add in another media query that's a little different, and I'm going to put, instead of just MQ, I'm going to put H, so I know I'm looking at height on this one. And once again, size variable, and at media only screen and min height instead of width, and the size, and here once again the at content. And then I've got one final media query, so a little more complex than some things I've done in the past. And here I'm going to say max, capital W for max width, and then min H for min height. So this is a media query that takes a max width and a min height. So we'll have size 1 and size 2. And here, just as a note, we can say what this is for. It's for an iPad Pro width of 1024, which is the width of an iPad Pro, and iPhone Plus 678 that has a height of 736. So this is kind of that fine line in between where we want things to appear a certain way. So I'll type media only screen and max width size 1 and min height size 2. And here we'll put at content, and we save that. Now we've defined our 4 mixins, and that completes the partial file for mixins. Okay, in completing these 2 mixin abstract, or not mixin, these 2 partial abstract files, they don't apply directly to the page. So we'd see no change whatsoever yet in our HTML here. I'll once again drag this down. But now when we create a base file, and that will go inside of our base folder, so we can do that with an underscore base.scss. These will apply, but we need to go ahead and import these others. So we've got our mixins. I'll copy this and put mixins, and then one more time, and instead of abstracts now, we've got base, and this will be a base file as well. So we're going to import anything from all three of those files. Now this will start to directly impact our HTML so we can see the change. So I want to have this open to the right so we can see both. I always start off with a CSS reset. And in a larger project, you may actually see the reset defined in its own separate file. Here I didn't feel like that was necessary. Start with a padding and margins of 0, and then box sizing. And I apply border box. Once we save that, you can see that instantly applied, and now the padding and margin that was default to any of those elements is gone. Everything is scrunched in just a little more. Now the HTML is the root element, and I have just a little bit more I want to put into this now. So I'm going to set a background color, and we have a background color variable we already defined in that colors mixin. And I will put in a background image, but I'm not ready to do that yet. So we're going to jump to the font size. And you can set a specific font size in the root element, and then later on you can use REM units, which stands for root EMs, and it will always refer back to this specific or absolute size you have defined. So I'm just defining 16 pixels as the absolute size. If I didn't put 16 pixels here, most browsers actually default to 16 pixels as the default size anyway. After that, font family, and this is where it's important to remember what Google Fonts told us. It said use Montserrat, if I can spell Surratt correctly, and after that use sans serif as the fallback. So we've got both of those defined. Font weight, I want this to actually default to bold, and then later on in the app, if we don't want bold, we can change that. But these will be inherited down to through the children or through the cascade of the style sheet. And now for letter spacing, I'll put 1 pixel, and color is the font color variable we already defined. And now you get to see an include of one of those mixins we defined. So we'll include the media query, and at 768 pixels, which is an iPad size width, we'll change that font size from 16 to 22 pixels. And it's important to do it here, although we may adjust font sizes with media queries later on as well. This is because anything referring back to this root EM, or this root font size using a root EM unit, then would be adjusted by just changing the root font size right here. So let's go ahead and save this much. And you can see things have changed over here on the page quite a bit. So we've got a default color underneath, and our fonts have definitely changed as well. Okay, now I'm going to scroll up, give us some more room, and we'll define some styles for the body element itself. Give the body a width of 100%, which isn't always necessary either. You could probably leave that out and it would default to 100%, but I like to have a definition there. Maybe it just makes me feel better. A min height, not a height, but a min height of 100 viewport units. And so that will make sure the height is at least as tall as the viewport, but it will still allow it to grow. Now I'm going to include another mixin we defined, and that is flex center. So this makes it a flex box, and it centers everything within. We'll change the flex direction to column. It defaults to row. And then we'll give the body just a little bit of padding. Here's one of those root EMs right there. And so now everything is centered, and there's just a little bit of padding along the edge. Not much, but a little. So we can see those changes. And now remember, our main element is the container element for everything. So while the body will actually be as big as the page no matter what, if we have a widescreen TV or a small cell phone, but the main element is going to be a container, and we will limit its size at some point. We'll scroll up again, and we'll start with the main. We'll give it a width of 100%, and then let's set a max width to 700 pixels. So not quite as wide as an iPad, but close. And then we'll go ahead and set a max height 1050 pixels. After that, let's give this a display of flex also, but we're not using a mixin we defined because we don't want all those other properties. We just want the flex display. We'll say flex direction will be column because this container will contain our 4 components that we defined with our section elements and the nav element, and we want those to stack on top of each other. It's also important that this main element grows to fill the height of the body as well. So it's not just partially as tall, that it is usually, or should expand, should always expand and fill out that page. Okay, the color will provide the font color that we previously defined, and then the background color, and this is the mask color. And the mask is going to put just a little darker shade over the area that is the main compared to the body. It will help the font stand out and be more readable, and it will also separate it just a little bit from the body. We'll apply a border of 1 pixel solid, and then we've defined a border color variable, and then a border radius of 10 pixels to round the corners just a little bit, and we'll apply a box shadow, and it's very small, 1 pixel for X and Y, 2.5 pixels for the blur, and then we have a shadow color variable as well. And let's scroll over just a hair. Let me see. Yes, we got that closed. Let's go ahead and save that. And we can see now we have this main element that is almost as big as the body, but the body has just a little bit of padding, and we can see the border all the way around it. And now everything in it is still stacked, and up here at the top, we haven't really said what to do with that, but we do have our separate section. It's also hard to tell now, so let me expand the page. And now you can see that this is just a little darker than the body on the left and the right, and that is because of that mask color that we have. Bring this back down, and we can go ahead and finish out the definitions in our base file. Okay, just a few remaining definitions, and they are generic ones that we keep here in the base file. For an image, we always want to put display block. Images usually have an inline display, and it can leave a little bit of space underneath, so we want to eliminate that. The horizontal rule, and we did put one of those in the page, we'll give it a width of 90%. We don't want it as wide as the full page. Margin of auto, so that will center it, and then we'll give it a border of 1 pixel solid and the border color. And then we need to define a couple of simple classes. One class will be none, and we'll just set that to display none, so we can essentially remove something from the page. And then we'll set the other one to block, and that will be display block when we want to show something that has previously been removed. Now that we've defined our none class, let's jump back to our HTML quickly. I want to expand the page again. And for each of those buttons that we defined, we have one in the search section. The animated icon needs to be set to the class of none to start out, because you only want to show one icon at a time. So programmatically with JavaScript, we will show the animation or show the actual icon that we have on the button. So we've done that for the search. I will collapse that section again. We need to go into our nav section now and apply this to all 5 of the other animated buttons. There's 1, 2, 3, 4, and 5. We can save that, and I'll go ahead and collapse the nav section again as well. Now when we bring this back and we look at our HTML, we can see the animations are now gone, and we're only seeing one icon at a time. Okay, we have completed our base partial, and we've applied the none class that was within it. Now let's move on to the components. And inside the components, the first partial I'm going to create is going to be named alley, which is A11Y, and this actually stands for accessibility. It's a common a abbreviation for accessibility, and I'm going to define some classes inside this file that I'm going to use for accessibility. One that you have already seen me apply, at least to the one paragraph that I said would make announcements, is the off-screen class. And this will have a position of absolute, and then we'll set it left and say minus 10,000 pixels. So this actually takes it off the screen, but not out of the page. A screen reader will still be able to read that. Now this is applied a few places in the HTML, and we will do that, but let's go ahead and define these other definitions first. And the next one is skip link, which you also saw me already apply in the HTML. And this is for those links that allow us to tab through the page and skip to different sections without having to tab through text or different navigation points along the way. So it makes the navigation of the page much easier. And we'll once again start with position, absolute. We'll set the top value to minus 999 pixels, the left equal to 0. The background is going to be text-shadow-color. That is a variable that was defined in the color partial. Padding, 14 pixels. Z-index of 1. We'll make sure this shows up on top when it does show up. And then the color will be the font color variable. And save that, and now we won't see that right away again, but we will eventually see it. You can see something has changed over here, hasn't it? But let's go ahead and add some pseudo definitions here too, because this is what will help make the skip links appear when needed. So we have the focus, and then we also have the skip link active. And we'll put top auto, and we'll put left auto, and we'll save that. Okay, jumping back to the HTML now, and I'll once again expand the page for a moment. We need to find everywhere that we need to apply that off-screen class, and the first area that we need to apply it, or the first element we need to apply it to, is this H1. We don't expect that to be on the screen, but we do want it to be readable by a screen reader, so we'll apply that there. The next place we want to apply off-screen is to the label for the input on the search bar. So not only does it have the for attribute for search bar text, then we'll give it a class equal to off-screen, and we can save that. And then the third place we want that off-screen applied is to the 6-day forecast title. So we'll scroll all the way down to the daily forecast, and where we have 6-day forecast here, so we want to also apply off-screen. And I believe we already applied it, yes, to our confirmation. So let's save that, and we would jump back and look at our page, but the first thing we need to do is include that partial back here in our components. If not, we won't see any changes. So we'll go import, and now we need to say components, and this is our ally mixin, and we save that. Now we should be able to look at our HTML. Yes, a lot of the things that we were seeing in the HTML have actually disappeared because we didn't intend those to be on the page, but they will be read by a screen reader. Now let's go back to the components folder and create another partial, and this one will be called buttons. So we start with underscore word buttons and .scss. And this will have the class for our buttons, and we'll start out by defining that base class before we get to any of the pseudo selectors, and we'll have a minimum width for our buttons of 48 pixels and a min height of 48 pixels. That is approximately thumbprint or fingerprint size, so that's always a good size to have. Color, we'll use a button text color variable that we defined. Border, 2 pixels instead of 1 that you might see me use more often. And that's, again, the border color we defined, 2 pixel solid border color. Border radius. We will make our buttons round. So this will be 80 pixels. We'll set the outline to none, but when we do that, we need to make sure later on with the pseudo selector that we do indicate in some way that the focus is on the button if you remove the outline. Font size, 1.25 REM. Font weight we'll make very heavy here at 900, or that could be what comes in from Font Awesome actually. Background color of button dash color. I was just thinking when I said comes in from Font Awesome, you might need to specify a font weight of 900 to get the icons to show, is what I mean by that. And then we'll include a media query and put 768 pixels. And font size is 1.5 REM. Min width of 64 pixels, so we're making the button a little bit bigger here, and the min height of 64 pixels when the page is larger. Once again, thinking back to that same thing I said about font weight, clearly the icons are showing. Sometimes in Font Awesome you have to specify a certain font weight, or specifying a smaller font weight will actually make them disappear. And so that is the thought process there at least. Okay, now let's define some pseudo classes for the button. We'll say button hover, and we'll change the cursor to a pointer when that happens. And then for the button hover and button focus, both, say box shadow, 4 pixels, 2 pixels, and then 5 pixel blur, text shadow dash color variable, and the border color will be the font color we defined. Okay, let's save that, and we're not seeing any changes yet because we haven't imported the buttons partial, so we need to do that. Copy this line, paste it here, and put in buttons. Now we see some nice changes to these buttons, and notice we're getting our cursor or our pointer, our cursor changed to a pointer when we mouse over, and we get that nice little shadow underneath, and they're definitely round, so that really changed those 5 buttons in the nav area. Notice our button up here didn't change. So we might want to see what we've applied or haven't applied to that, and we probably have some extra styles because it's not quite the same as these other buttons that may be applied within its specific component definitions as well. Let's jump back to the HTML quickly and see if we applied that button class at all to that very top button in the search bar. We expand our search bar section, we find our button, here's the class, it has search bar 2_ button, which is different than just applying the button class itself. The search bar 2_ button class, the first class, this is something we might apply as we define that section just a little bit more. But let's go ahead and apply the generic button styles that apply to the other buttons as well. And we'll bring this back over. And now you can see this is really big up here. What this is probably going to change is we don't expect that to fit inside the search bar as we see here in the final result. But it doesn't hurt to go ahead and apply that for now. As we're finished with components for now, I'll let that collapse. Now in the layout folder, we will have a partial for each section of our single page application. So we have our search area section, we have our current forecast section, we have our nav bar or nav button section in this case, and then we have our 6-day forecast. So we expect to have 4 partials as we have 4 sections. And the very first one will be the search bar. So let's start out with an underscore search bar.scss. And instead of waiting until the end, let's go ahead and import it now that the file at least exists so it won't cause an error. So I'll say layout and then search bar. And now as we apply changes, we should be able to save and see those applied rapidly, and there will be several here. We'll start with the search bar class. And one nice thing about using SCSS or SAS is that it allows nesting. So now anything we nest in here, other classes specifically apply to anything that is a child or in the cascade of the search bar class itself. First thing I'm going to do is apply some padding here. 0.5 REM on the top, 0.5 REM on the right and left, and 1.5 REM on the bottom. Now if I save that, we instantly see that padding applied here, and we can definitely see it happened at the top. But now we're going to nest the next class here. So it will be search bar, 2 underscores, and form. We'll give it a display of flex. We'll justify content and set this to space dash between. And then the border will be 2 pixels solid, and the border color we previously defined in a variable. And the border radius, this is what really rounds those edges to make it look like a good round search box. So let's save this. And now you can see that border that we put on here is really rounded. It kind of matches this circle button we have here. And it's rounded here, but the text box is currently over it, so you can't see the rest. But now inside the search bar form, we can nest the next thing, which is the text. So here we'll put search bar text. So this is really following kind of how the page is nested, because the text input is inside the form, and the form is inside the search bar section as well. Now we're going to set this text input to a flex grow of 1, so it fills everything out. We'll set a border to none. We'll give just a little bit of margin on the right so it doesn't crowd the button over there. And then we'll set a background color. And let's set that equal to, it says button color, which is a little unusual for a text input, but if you remember, the button color variable is transparent, and so that's what we want right now. The color itself for the font color will be the font color variable we defined. And now let's give this a width, and the width is going to be defined using this calc method, and we'll give it 100%, but then we'll subtract 52 pixels. Now remember, our button would be around 48 pixels, and then there's just a little bit of margin, so we're giving it just a little bit of extra room there. And then the font size, set to 1.25 REM. Padding, 0.75 REM on the top, 0 on the right, 0.75 REM on the bottom as well, and 0.75 REM on the left. Those rem units, I keep saying REM like the old band. And let's set the outline to none. Now if we save that, we see a big change. Not everything has changed yet, but it's a nice change so far. Okay, let's scroll to give ourselves a little bit more room. And just underneath that, we'll add the search bar, 2 underscores, text, and then a placeholder pseudo style here. And this color will be fade color, the variable that was defined. And underneath that, we need to define the search bar button style. It's 2 underscores and button. And we'll have a hover and a search bar, 2 underscore button, and we'll have a focus. Here we'll set the border to none. A box shadow, oh, you know what? I jumped over the definition I needed to do. After the placeholder, I actually needed to just define the search bar button first. So I'll go ahead and do the pseudo styles, and then we'll jump back up. So after the border is none, we'll do box shadow and set that to none, and then a text shadow, 4 pixels, 2 pixels, 5 pixel blur, and this will be that text shadow color. We can save that much, but I have skipped over something, so let's jump back up here. And after that fade color, we need to just define a search bar, 2 underscore button, and set the border itself equal to none. And then inside this, nested inside the search bar button, we have the icons. So it's that icon element, but this will only apply to icon elements inside the search bar button, which would be our only magnifying glass up here. And we'll set this font size to 1.7 rem. Okay, now we can finish out by defining our next and final style here with search bar _form focus dash within. That's a pseudo selector, and then a search bar _form hover. And here we'll put a box shadow. And this is on the entire form actually. So a box shadow, 2 pixel, 4 pixel, 5 pixel blur, and once again that text shadow color variable. So now we mouse over the entire form, it gets that shadow. And now that we're finished with these styles, I can tell there's one problem and we're still seeing the white text box here and something's not applying quite correctly. So let's go ahead and scroll up and see what's going on with the text box, the search bar, 2 text. And yes, a quick look shows I put a $sign in front of the background color, which is a variable rather than just saying this is a property. So let's save that and see what changes. And there, just as it should be, now it has that transparent background color and we see everything that we want to see here, including the placeholder text. Okay, now that we've completed our search bar partial, let's go ahead and we're going to jump out of order here. So instead of going to the current conditions, we'll define our nav buttons partial. So we'll start out with nav and then a capital B for buttons and then end with .scss. We need to scroll down and include that once again in our main with the import. So we'll copy that search bar line. Once again, it'll be layout, and then this will be nav buttons. Save that, go back to the nav buttons file, and this is not long at all. We'll define a nav buttons class. We'll apply flex grow here of 1, and then we'll include the flex center mixin that was previously defined. And then we'll override the justify content that's inside that with a space evenly. And then we'll apply padding of 0.5 rem on the top and bottom and 0.25 rem on the left and right. We'll save. And now our buttons look spaced according to the way we planned. And if you wonder why this is down here now, it's because it's set to flex grow. So it's filling out the space that is not currently occupied with that flex grow property. Okay, our current forecast and daily forecast partials remain, and those are dynamically created. So let's go ahead and create these files first. Not the styles aren't dynamically created, but the content is for these sections. So we'll have a current forecast and an underscore daily forecast partial. And let's go ahead and import both of those while we're thinking of it. I'll just paste twice and we'll have one say current forecast and the other can say daily forecast. And now that that part is completed, let's talk about the dynamic content. Right now, when you follow a tutorial, I have pulled in this content in the past and created a finished version, of course, that I'm working from. But when I first pulled in this information from the API, I didn't know how to style it, and it takes me a while to play around with it. Actually, I prefer JavaScript. I'm not as good at styling, so styling can take me quite a while. But now I'm just going to show you essentially the finished version of what I've created. But feel free to play around with this and make it your own, because that is another way to learn and to do your own styles. But right now we'll follow what I've put in. So in a different way than the way I did it, which was bring it in and not knowing how I wanted to style it, I've already brought it in. And in this instance, to be able to style it, I need to go ahead and paste in some HTML that would normally be dynamically generated. but I'll just paste it into this section right now so we can go ahead and style it. And then later we'll remove it and we will dynamically generate that content. Let's collapse the search bar here. So in the current forecast section, and then in that section, it is the current forecast conditions. And this is where the content is dynamically generated. So I'll paste in some content that is dynamically generated, but I've already just pulled it out of the existing page that I'm displaying as an example. So this is our content that is later dynamically generated. Let's save that. Now if we look back at the page, you can see here's that information pulled in now. You even see the icon from Font Awesome here, which is kind of cool, but we'll change that as well. So we'll learn how to style all of that as we apply it. Now let's do the same thing to the other section, and that is the daily forecast contents down here. Create a big opening there just to paste in so it'll be easy to find. And come back and paste. And wow, that looks like a lot, and it kind of wraps. It's a little hard to read right now, but that's okay because we're going to create this dynamically. What we want to do right now is be able to style it. And here you can see everything that we've pasted in is showing up here now. So we'll first apply the styles, and then we'll go about creating this content dynamically as we cover the JavaScript. So back in the styles, we've already imported. Do we create these? Yes. So we're ready for the current forecast styles. Let's go ahead and make the window smaller again so we can see things as they are applied. Scroll down here and we'll start at the very top with the current forecast class, and everything will be nested inside of it. And immediately we'll go to the current forecast 2_ location. We'll give that a font size of 1 rem. Font weight. Here we'll make this normal, where we were inheriting bold from the root element. Text align will be center. Margin on the bottom, 1 rem. And then we'll include the media query, 768 pixels, so that's iPad size. We'll say font size 1.3 rem. Now, this current location or current conditions here, it says current forecast location, is right here, current conditions. But this will display the location or the latitude and longitude, as you see here in the example when we've hit the location button. So this is either going to display the name of the city or country that we've looked up or the latitude and longitude. And if it doesn't know what to display, then it will say current conditions. Okay, after this current location definition, we can scroll down and define current forecast 2_ and conditions. And this will be the conditions that we've pulled in over here. Okay, a width of 100%, font size 1.1 rem units, margin of auto, that would be top, then auto left and right, and then 2 rem on the bottom. Display is going to be grid, so this will definitely be different. We'll include a media query, and the first media query breakpoint will be 375 pixels, so not too wide. So first of all, we're talking about using the smallest phones first, so anything wider than 375 pixels will get this style applied to it, and that'll be 1.3 rem instead of 1.1. So you can tell our default definition was for very small phones. Then we'll include another media query and set that at 400 pixels, so not much wider actually. And there we're setting the font size to 1.7 rem. And let's save that much. Now you can see a few things have changed over here. Let's also go ahead and change this view to a phone, because that is definitely how you want to view things first, and we might even break it down to a smaller phone like the iPhone 5. Right now this is a 6, 7, 8 Plus, I believe, but we'll stick with this size for now. Okay, also inside the current forecast conditions that we've started here, and I'm using the bracket pair colorizer extension so you can see these colored lines, but we're going to stay inside this definition and have a class of temp. And we're going to include the flex center mixin. Now we'll start defining our grid, and I'll get the grid defined and then I'll explain the grid more or less. So we'll start with grid row and start at 1, and then it will span 3 rows. The grid column, this will start at the first column and it will span, I needed a slash there, it will span 2 columns. I'm going to set a font size to 6 rems. That's pretty big. Letter spacing to 0. If you remember, we did have a default letter spacing in the HTML root of, I believe, like 1 pixel. So we just set it to 0 here. Text shadow, 1 pixel, 0, a 5 pixel blur, and our text shadow color variable. Position is going to be relative, and that usually means we're going to position something absolute later on that's related back to this. And this is going to be, by the way, our big temperature that we're seeing right over here. This is the temp class. Okay, after the position relative, we're going to include a media query for this temp class. Media query is going to be at 360 pixels. Once again, fairly small there. Font size of 8 rem. And then after that, we'll include a media query more at the size we're used to seeing, at the tablet size. And there we'll increase the font size to 9 rem. And let's save that much. There we see a nice big 59 degrees Fahrenheit, but we need to define the rest of our grid because just defining part of the grid doesn't work out too well. So remember, we're still nested inside of the current forecast conditions, and there we did our temp class. Now the next class to do is the unit class. We'll give this a font size. Let's make sure that this unit class is not nested as well. I want to make sure it is nested inside the temp, and I thought so because notice how big this F is here for Fahrenheit. Here is our F right here. And while we said this was relative, this unit indicator, whether it's Fahrenheit or Celsius, is going to be positioned absolutely in relation to the temperature. So that's what made me think about that being possibly inside there. And yes, the unit is nested inside the temp. So if we break that down, let me save over here. There, it positioned it right. But we need a font size. We didn't finish defining that. So 1.65 rem. After that, color is a fade color variable. And then the text shadow will be none. Position for this is absolute. And again, this is the F or the C to indicate Fahrenheit or Celsius. Okay, after position, we have a top of 55% and a left of 85%. And we're going to include a media query. And this is again at tablet size. We'll make the left 75%. And let's save that. And now you can see the small f of the Fahrenheit, which would eventually turn into Celsius if we went over to the metric system. And if we switch here, you can see it in place right here in the finished version. Okay, so unit was nested inside temp, which we see with the blue line, but nothing else should be nested inside temp. So we'll break this down. And now we'll have a icon class definition. And we'll include our flex center mixin. This will start with a grid row at 1, and it will span just 1. and a grid column of 3, and it will span 2. Now inside the icon class, we can put styles for the icon element. And here we'll have a font size of 3 rem, text shadow, 1 pixel, 0, 5 pixel blur, text shadow color variable, and again a media query. That's 768 pixels. And here we'll set the font size to 4 rems. And this is the icon that we see up here now. Things changed quickly there as we defined a little bit more of the grid, but we put the styles we applied there to this icon. Let me scroll back over, and you know, I could actually hide the file tree to make this a little easier to read now, which is probably a good idea. So there's our icon definition. And we come down underneath that, we can set a max temp class. And we'll include our flex center. Mixing once again. So notice we're using flex boxes inside the grid because grid and flex box can be used together. We'll set an align self to start. The grid row will be 3 and it will span just 1 row. The grid column 3 and it will span 2 columns. And then the color will be the fade color we've defined. We save that. Notice our high now has a faded color and it's right here. And now the max or the min temp we need to define as well. And it will be very similar. Actually, I was reading wrong and I applied the min temp styles to the max temp. So I'm just going to paste those in and save. And now, of course, they're right over each other. Let's go ahead and change that max temp. It gets the flex center as well. It does not have the align self. Grid row instead of 3 is 2, so that puts it on a different row. As you can see, they're overlapped right now when they had the same styles. Grid column 3, span 2, that is the same. And it does not have the fade color. Now let's save that, and now we see the high above the low, and the high has just a little brighter color than the low, and that's what we wanted. So this is starting to come together like the finished product now that we see over here. Moving on, we need a description class. It's .desc, and it will have a flex center as well. And then its grid dash row will start at 4 and it will span 1. And then grid dash column will be 1 and it will span 4. And then we'll have padding dash top and 0.5 rem. We also need to include a media query here, but this is different. We'll include that MQ and then max width min height media query. This will be 1024 pixels. That's the max width, and that is also the width of an iPad Pro. And then 650 pixels as a min height. So only the taller phones or tablets will see this. So anything larger than a tablet, this won't be seen on. And likewise, only the tallest phones will allow this to be seen. And here we'll put in a margin top 1.5 rem, and let's go ahead and add one more media query here on the description. I said allow this to be seen. Well, it will only apply this margin on the top when these media queries are true. It's not hiding or showing something, but it's just applying the margin. And here we'll say margin dash top of 1.5 rem as well. So if we have a minimum height of 1080 pixels, it's going to show anyway. So it's looking for this or this to be true, and then it will go ahead and apply that margin top. Okay, now we need our feels class, or feels like. This is also include flex center. And we'll have a grid dash row 5 slash span 1. Grid column 1 slash span 4. Again, we will break this grid down in just a moment to see all of that as soon as I've applied it. 0.5 rems for the padding. Font weight is normal. Let's save that. Now if we look over here, you can see our clear sky and feels like. And notice the clear sky has more of a bold font, and then feels like has this normal font weight. And that's what we've got right there. All right, back in our section, our feels like doesn't quite look like it applied yet, so I might need to see what's going on there. All right, let's keep moving for now, and we'll add the humidity. But the humidity is only seen on a little bit larger screens. It doesn't start out being visible, so we'll give it a display of none. But if it is visible, it will have a grid row equal to 6 and then span just 1, and a grid column of 1, and it will span 4 columns. The padding dash top 0.5 rem. Font weight will be normal. The color will be the fade color. And now we have the media queries that will make it be visible or not. It starts out being not visible. And again, this is the max width, min height. We start out with 1024 pixels like an iPad Pro. Minimum height of 700 pixels, so tall phones and iPads will work. And then we apply that flex center class. Also, we'll apply the other media query here, media query height, there we go, MQH, of 1080 pixels. So if it's at least that high, then it will be displayed by default as well. And if we save that, it looks like we have an error, and that's why this is not applying. So I will check out that error real quick. So yes, we have an error. If you pull up the display where it has the output from SAS, you can see it gives you some more information, and it says I have an undefined variable as I'm looking at this media query. So that tells me actually something we did back in our mix and definition probably has a typo or some type of error. So I'll scroll this down again, or pull that down. I'll show the file tree. Let's go to the mixins. Here I'll close this open editors thing so it's easier to see. We're going to our mixins file, and I'll look at our definitions, and I can see, yes, in this max width, min height media query, let me hide the file tree again so it's easier to see. You can see I refer to a variable size 1 and likewise size 2. However, in the definition, in the parameters, I just passed in size and size 2. So this needs to be size 1. And if I save that, probably all will be well. And yes, things are applying over here much better as I expected now. And we've got the clear sky, feels like, and humidity. The only thing we haven't changed is the wind. So it instantly updated as soon as we fixed that. I'm going to show the file tree again just to get back to the current forecast, and then hide the file tree. And we'll go ahead and scroll down so we can get to the next definition after humidity. And that next definition is the wind class, which is also the final class and definition for this partial. So we once again start with display none, and then grid row 7, and it will span 1. Grid column just 1, and it will span 4. And then we have padding on the top, 0.5 rem. Font weight will be normal. Color will be the fade color. And we'll include these same media queries that we did for humidity as well. And if we save that, now we have the wind and the humidity. The color is a little more faded here than it is for feels like, and feels like has the normal font instead of the bold font, even though it's not faded. Clear sky has not only the bold font, but it is not faded at all. But that takes our current weather section here. Now, talking about the different sizes and if something would appear or not, let me scroll or pull this over a little bit and we'll get a little bit of room for the browser. There it is. I want to be able to switch the phone from the iPhone 6, 7 Plus down to the iPhone 5 SE. And now notice the humidity and the wind disappeared. We don't have as much room, especially height, if we want a single page app that doesn't scroll, and that's the idea behind this weather app. You want everything accessible right away and it's not scrolling. So a smaller phone just doesn't display the humidity or the wind, whereas a larger phone like the 6, 7, 8 Plus will display the humidity and the wind as part of the overall current conditions. Okay, we'll pull this back over and just give ourselves a little more room for typing the code. And we're ready to add our last partial, or we've already added it, but we're ready to add the definitions now under the daily forecast. Okay, I've got just a bit of a gap here. I'll drag that over, clear out that default Chrome message. Let's also take a look at that grid layout now that we've defined it. I'm going to right click and choose inspect just so I can highlight parts of the HTML. And you can see when I mouse over the element over here in DevTools, even though I'm not showing it all, it displays the grid. And so if we count the rows, we have 1, 2, 3, 4, 5, 6, 7. And so that's what we defined. And when we said a row had a span of more than 1, that's what it was actually taking up. So if we look at the temperature there, the 59 degrees, it is taking up 3 rows, had a row span of 3. Likewise, if we look at some of these other definitions like clear sky, it has a column span of 4. So we were saying what row to start in and then how many columns were spanned. And likewise, we could also say how many rows were spanned if we did span more than 1 row. And so take a look at that layout, and there are some good grid tools. I don't want this to be a full grid tutorial, but you can break this down and just look at this picture or do a screen capture and then look back at the definitions that we posted. So if we look back at our current forecast definition and starting with that temperature, you can see we had a grid row of 1. We started in row 1. But we spanned 3 rows. And we had a grid column of 1. We started in the first column as well, but it spans 2 columns. Likewise, when we got to the icon here, grid row of 1, and it only spanned 1 row. And then a grid column of 3, so it started in column 3, and it spanned 2 columns. So you can see how that breaks down. And you could break that down throughout the grid, and that is how you map those out as well. Okay, now let's head back so I don't turn this into a full grid tutorial. But that should give you a good start or something to go from, for sure, to break this down and see how it all applies. Let's now go back to the daily forecast and apply those styles as well. We'll start with daily forecast. And then immediately nested inside of it is the daily forecast, 2 underscores, and title. We'll give this a font size of 1.1 rem, and then a text align of center, a margin top of 0.5 rem, and we'll use a media query. Here we'll pass in our tablet size. And at that point, we'll switch the font size to 1.3 rem. Let's save that. And now we can see some of this change down here. But let's move on to the next. After the forecast title, we should have the daily forecast 2 underscore and contents. And now we want this set to a flex grow of 1, so it also expands. We'll include the flex center as well. But then we're going to override that center for justify content to a space evenly. And then we'll have a color that is the font color, variable defined. and padding on top and bottom of 0.5 rem, left and right of none. Okay, after that, we're going to nest in the forecast day, because now we're just inside the contents here. And we'll display flex. Now each day will have its own column. And we'll justify content. And we'll space evenly once again. I need to hide that file tree. It's in the way. Sorry about that. There we go. And then we'll put align items to the center. And font size 0.9 rem, just a little smaller than the default. And include a media query, 375 pixels. So again, the default was only for the smallest phones. And here we'll set the font size to 1 rem, which is where we'd prefer it not go below, but occasionally it can happen. And that should end those definitions. We do have an error. You can see I put column, and that is not correct. We need flex direction, and then that is the column, and we save that, and wow, that made a huge difference right there. Okay, this looks good, but what we haven't done is apply any images yet. This is our default background color, and it works, but this app does have the ability to dynamically change the background and color based on the weather information it gets. And we need to start out with some images as well. So let's go back to Visual Studio Code, and I'll press Control B to show the file tree. Now in our distribution folder, we need to create another folder and name this IMG for images. And I'm going to paste in some images that I will also have in the source code repository. But you could also grab your own images from unsplash.com is a great place to look for images of rain and snow and all of those things. So find what you want that works best. Here I've got clouds, fog, night, rain, and snow. And we'll use the clouds as the default. So I'll go ahead and collapse this. Now we'll go back to our base partial. And from here, I'll hide the file tree again and scroll to the top where we can apply this image directly to the HTML element. Just underneath the background color, we want to specify a background dash image, and here we'll use URL and quotes. And now we need to consider this. When I type 2 dots, it's going to respond, or VS Code's going to respond, as if I'm in the SAS folder, this SCSS folder, and then the base folder within that. However, that is not where I am. So I don't want to choose something from abstracts or think I need to go up another folder. Actually, this will be compiled to the CSS. So you have to think about it like you're in the CSS folder. We went up one level. Now we're going to go into the image folder that is next to the CSS folder within that dist folder, our distribution folder. And from there, we'll pick our clouds.jpg image file. So that takes just a little bit of thinking about where you are and not responding to what VS Code actually shows you. After that, we'll have background-size. We're going to set this to cover. And let's go ahead and save that much, and then we'll see what the last style does here after I apply it. There we have our clouds behind it, but notice how hard that is to read. That white font we're using, font color and everything, just doesn't go too well on these light clouds in the background. But we can make this easier to read, and we can use a background-blend-mode and put overlay and save that. And wow, that made a huge difference. That overlays the background color that we had, which is a blue, and we're also applying that mask. If you remember, we had a mask color, so the mask is different, makes it a little darker there as well, which also makes it easier to read. So let me expand this in the browser, and then I'm going to go ahead and break out of DevTools for a little bit. And you can see how, yes, even this is blue, but this is even just a little darker inside here where I applied that mask color to the main element. So now I'll make this a little smaller again, and we'll go back to DevTools to get the phone view. But that makes a huge difference in the readability. It looks like I need to reload it to get the right size going. There we go. We've got the right size now as it loaded correctly into DevTools. But that certainly helps the color and the appeal. Now we will change the image and the color programmatically based on the weather we get in. And that leaves another partial to define. So let's create our new partial in the themes folder. So we'll highlight themes and we'll create a new file there and we'll call it underscore backgrounds.scss. And in the backgrounds partial, we'll define the different classes we expect for the different types of weather. Now, sunny or partly cloudy is our default, and that's what we've already got in our base file. So we'll just apply these classes when the weather is different than that. And we'll start with rain. And for rain, we'll have a background color. We'll set that equal to the background color. So it will remain the default blue that we've already had, but just in case it's changing from one of the others that actually do change the background color, it's good to go ahead and set that at that point. And then we'll apply background image and we'll use URL. And here we'll go up the folder and then into the image folder, and then it will be rain.jpg. And that's really all we need for that class. Let me go ahead and once again hide the file tree just so I have a little more room to work. And now I'm just going to copy this because many will be very similar and they're all setting these two properties. So after rain, we'll define snow. Snow will also use the default blue background, but it has a snow image. And after snow, we'll have night. Now night, we do apply a different color, and that one was defined as a variable called night color, and it will have a different image called night. And then we're going to create a fog class. There's fog, and the background color for fog will be the fog color variable we've defined, and it's also going to have its own image for fog. And we have one more, and oh, here's the clouds. So I guess even though we do have it as the default, when it changes out, it's good to have one change back to. And so, well, here instead of this, I'll go ahead and paste one more time, and we'll call this clouds. And then we'll have the background color be the default blue again. So you can see it only changes on a couple of them, the fog and the night. The rest it stays blue. But you can play around with this and make your own as well. And then we'll have our clouds.jpg or JPEG for that. But these will all be applied programmatically. None of these are being applied right now, but we do see the default with clouds, or also this is what shows for sunny weather in my version. Of course, you will be able to define your own. Now there's one more partial to actually to define and apply, and it's in the components folder. And this partial we're going to call fade in. So I'll create one more file, be underscore fade capital I in.scss. And we also need to include that last one from themes, the background. So let's go to the main and copy a couple of lines here. And the first one, we'll change to themes and change this to backgrounds. And the other one is coming from components again. So we'll copy one of these components lines, paste it, and then we'll put fade in. And this is where I'm putting an animation. And this will kind of make it look cool when it first loads or we look up another location. So let's start defining this. And the first class we'll have is 0.-vis, or visibility. And I'll put in visibility, and we'll set that to hidden. And now we'll put the opacity at 0. And then we'll have a fade in class. And here we'll set the visibility to visible. Set the opacity to 1. Now we need an animation dash name, and we'll call this fade in opacity, because that's what it's going to do. Animation iteration count of 1. Animation timing function, and we'll make this ease, geez, if I could spell, ease in, and then we'll have animation dash duration, and we'll make it 1.5 seconds. We'll save that much, and now we need to define keyframes for the fade in. So here we'll have at keyframes, we'll call it fade in opacity, we have to pass the animation name there. At 0%, the opacity will be 0. And then at 100%, the opacity will be 1. And that defines the fade in. Now we need to apply it in the HTML. Going to the HTML, we will apply this fade in class. I'll once again hide the file tree so we can read the HTML a little better. Let's apply it to the main element. It's fade dash in. And I'll go ahead and copy that. And then we want to apply it to our sections that we have. So we've got class search bar, and then we'll have fade in. And I didn't paste that in the right spot. Let's back that up, and class search bar and fade in. And then we have our current forecast section, and it has the current forecast class, and we'll also apply fade in there. And then we'll move down to the next section. It looks like I need to collapse this section. We have the search bar and line 27. Then the next section that we could use is the nav, possibly. And I'll apply the fade in class there. And the next section is the daily forecast, but let's also not forget the horizontal rule, and we'll apply it there too, and the daily forecast. And we'll apply all of those. Now when we reload, our app fades in nicely. I'll do that once again. And we get a nice transition there. And of course, when we get new weather details, it will fade from one to the next. And that will be a nice addition to our application. Now that we've finished our CSS, our SCSS styles, and we've completed our HTML, let's go ahead and expand VS Code quickly. And we'll expand the file tree by pressing Control B. And now we can close up everything in the SCSS folder. Looking at our dist folder, what we're ready for is the JavaScript. So let's highlight the dist folder, create a folder named JS. To get started with our JavaScript, the first thing we want to do is pull out this content that we were creating that is not really going to be there. We're going to dynamically create this with JavaScript. So let's go ahead and pull out everything that would go in that daily forecast div. And then let's go ahead and pull out everything of the current forecast that we really will create dynamically as well. And so that is everything that I had inside this current forecast conditions div, because that is where we will put all of this dynamic content in those two. Also at the top of our HTML, maybe just underneath the link to the CSS, let's put in a script tag, and the script tag is going to have a source equal to our JS folder, and we haven't created it yet, but it will be our main.js file. And let's also put type equals module, because we will be using ES6 modules with this, and save the file. Now in the JavaScript folder, or with it highlighted, let's go ahead and click New File and create our main.js file, and we're ready to begin writing our JavaScript. We'll start our JavaScript file by defining an init app function. So we'll start with const and then init app, and no parameters. It's an arrow function. And now inside this function, which will be called when the app loads or initializes, we'll have our listeners, and we have to think about the pathways for actions within the app, because that's what JavaScript does. It makes our app interactive. So we have 5 buttons, and let's take a quick look at our example. Now here we've cleared out our dynamic HTML, so The one we're working with is kind of blank, but you can actually see what we can interact with. We have a geolocation button, we have a home button, a save button, a change units from imperial to metric and back and forth, and then a refresh button. And then we also have a search box to interact with. So there's actually 6 ways to interact with the app, and that's not counting when we load, which is the actual init app function that will be called as well. So a user can also load the app, and that creates a response. So we have to handle the load, and then we have to listen for events caused by each one of these 6 possibilities. Okay, back in the code, we'll just handle one at a time. So I'll put add listeners here because we'll listen for these events. And after we listen for the 6 different events that could occur, we're also going to do just a little bit of setup. And finally, we'll load the default weather at the beginning of the app. So those are the 3 things we're going to do inside the init app function. And then we'll call that function when the page loads. So we'll add an event listener to the document. And let's listen for the DOM content loaded event, and then we'll call init app, and that will launch our app into action with the listeners and the setup. So let's save this much, and then we'll tackle each one of these in order. But the first thing I want to do before that is actually create a current location class, and this current location class will handle the data for the current state of the app for where it thinks our location is. And so let's go ahead and create a new JavaScript file. I'm going to name this with caps, as you would with a class, so current location, and this will be a JS file. And now let's start this with export, because we'll be exporting this class. So export default class, and then current location. And now we'll have a constructor. And in our constructor, now JavaScript is working on making private variables and properties for classes. And it is supported somewhat, but not enough that I want to use it yet. So I'm going to use this and then an underscore to indicate that this is a private property. I believe when they are adopted, you would actually use the pound symbol, or the hashtag, if you will, to indicate that it is a private property. So you could look that up on caniuse.com to see how well it's supported right now. I'm going to default the name to current location, and of course this can be replaced by a location name that exists, such as Kansas City or Tokyo or whatever. This _lat for the latitude. We'll set it to null if it doesn't have one. The same for lon for longitude. And then this _unit equals, and we'll default this to imperial. Now maybe you want to default this to metric. It depends on where in the world you are, but I'm going to start out with imperial. That's what I'm used to. Okay, after the constructor, let's create getters and setters for these different properties. Now, I like to use, instead of the actual get and set keywords, I like to use method names that spell out exactly what they are. So while the get and set keywords do exist, I like to create them more like this with get name, and then we'll return this _name. And that would be my getter. Likewise, set name, and then you pass in name, and then this _name equals name. We're going to do this for each property. So the next is get lat, and we will return this _lat. And then set lat, we'll pass in lat, and from there we'll have this _lat equals lat. And I believe you can see the pattern here. We'll start with get lon. We'll return this _lon, and then set lon, and we'll pass in the lon for longitude, and this dot underscore lawn equals lawn. Let me scroll just a little. Now we'll get the unit, return this dot underscore unit, and then we'll set the unit by passing in the unit and have this dot underscore unit equal unit. Finally, we need one additional method in this class, and this is to toggle the units. I'll just call it toggle unit. And here we'll have this dot underscore unit equals, and I'm going to use a ternary statement. So we'll look at the current unit, and if it equals imperial, then we'll switch it to metric. Otherwise, if it's not equal to imperial, it's going to be metric, so we'll switch it to imperial. So we've just created this toggle method for the units. And save that, and we're finished with our class. Let's go back to our main.js file, and we can import this class. We'll do that at the very top of the file. So we'll start with the keyword import, and then specify current location, and then we'll say from, and we'll specify the file, current location, and I'll put JS there. When you use some bundlers, you don't have to do that, but if you're just working with vanilla JavaScript, specify the entire file, and then I'll have const current loc is what I'll define this object as, and then I'll say new current location. And now we can refer to current loc as our location state throughout the rest of the functions we call, and we'll pass them into some functions as well. Now let's start with the first event listener, and we'll work with the geolocation. So I'm going to define the geo button, and then I'm going to grab that button with the get element by ID, and I believe we gave it the ID of get location. From here we'll say geo button, and then we'll add an event listener. We'll listen for the click event on the button, and we'll call get geo weather, which is a function we'll now need to go define. So just under our event listener for the DOM content loaded, let's define this get geo weather function. There we go, get geo weather, and it will receive an event. It's an arrow function. And now we'll do a couple of things in here. We really want to work with the geolocation built into the browser. But I'm going to listen for the event first with an if statement, if it's a click event, because we could call this get geo weather without a click event. And so here I want to say if event.type equals click, and then we'll know the button has actually been clicked or pressed. And we can do something specific in here, and this is what we're going to do is add a spinner to that button. We're going to actually animate the button like we had talked about when we were setting those up. And then after this if statement, we'll call on the navigation or the navigator.geolocation that's built into the browser. And the navigator keyword goes way back to Netscape Navigator, but it's still around. So here it's like if we do not have, that's what the exclamation means, if it's false. If we do not get a geolocation, then we're going to call our geo error callback. Whoa, that's not what I wanted. I just wanted geo error, and that's not helping me type that. Here we go. And then I'll just backspace it up. We'll call our geo error callback. And then otherwise we do have it, and we'll say navigator.geo, no, it's all lowercase, geolocation, get current position method that's built into the geolocation, and we can call the geo success callback or the geo error. So what this first if statement is saying is basically if the navigator.geolocation is not supported. Otherwise, the get current position could also have an error and call this geo error here. but it's good to check to see if it's supported first. So now we have geosuccess and geoerror callback functions to go ahead and create, but we also have this add spinner section. So let's also add the code for that. And we'll first start out by defining this map icon that's on the button. So we'll use document query selector, and we will select that font awesome icon, map marker, there it is, -alt, that's on that button. And then we're going to call another function we'll create, and this will be add spinner, and we'll pass in the map icon. Now we don't have the add spinner function yet either, and we're going to create that in a file that is imported. So let's go ahead and do that, and that will be a DOM functions file. So before we save this, it'll probably create an error if we don't have these functions. I'll come over to the JS folder, and I'll create a file called DOM functions. Going to break out what we can into DOM and data functions, the functions that kind of intersect or are more procedural that need to interact with both will be here in the main JS, but we'll limit that where we can. And so now in the DOM functions, we need to create this add spinner function. So we'll start with export const add spinner, and this will let us export it over to the main file where it will be imported, and we'll pass in the element. And now inside of this function we'll call a helper function that actually animates the button, and I'll explain why. So we'll call animate button, and I'll pass in the element. But then right after that we'll also set a timeout with the window.setTimeout, and you don't have to put window dot, it's just understood in JavaScript. And we'll call this animate button function again. And then it will be called after 1,000 milliseconds, which is 1 second. And then we'll pass in the element. And that is a sometimes little known third parameter of setTimeout, where you can actually pass in a parameter after you set the timeout seconds. So here we're calling this animate button twice, and that's why we have a helper function. It helps keep our code dry, because otherwise we would have to have a anonymous function here and type the same code that we did right above it as well. So let's go ahead and create this animate button function, and it does not need to be exported. It's a helper function, and so just by exporting add spinner will be able to call the animate button function. So it's going to receive the element as well. And now inside the animate button function, we're going to use the element and then look at the class list. And this will be the icon that we selected there that we're passing in as element. I actually probably should have used the term icon, but we're using element. And I'll say toggle. I guess it is the button, so we're throwing the class on. Well, I believe it's the icon. Anyway, we're throwing the class on there, and it will be none, so it will be hidden. And then after that, we're going to get the one next to it, because remember those two buttons are those two icons. There I go, mixing up the terminology again. The two icons are side by side. And so instead of just element class list, it will be element next element sibling. So that means get the one right beside it and get the class list from it. And then we'll toggle the block class we set to display. And we'll also need to toggle the none class on it, because you don't want it to have both block and none at the same time. So we add one, we remove one. Whichever one it has will be removed, whichever one needs added will be added. And that is the full function there. So again, it's putting none on or removing none. It toggles either way when you call this toggle method. And that shows the default or hides the default icon. And then the other one next to it is the animated icon, and it either shows it or hides it, depending on what is needed to be done. So let's save both of those. And now we need to go back to the main.js file. And on the main.js file, we need to import this function. So once again, at the very top, I'll start with an import. And then it looks like an object here, and we can name functions we're importing. And I'm going to start with add spinner. And in the future, we'll put a comma, and we can put more functions after that. Here I'll say from, and then ./domfunctions.js. And we can save that now. And now we're importing our add spinner function from DOM functions that we've created here, our module, and we can use it down here. Okay, we haven't defined our geo success or geo error yet, so let's just temporarily comment these two lines out so we can see if our add spinner works without getting an error. So I'll save this after those lines are commented out. Now let's look at the browser with our example here. We've removed the dynamic HTML, so we're just seeing the buttons and the search area. But now we should be able to click on our location button, and it should animate. And yes, it works as we expected it to. That's great. So now let's come back and uncomment this. Go ahead and save the file again. And we're ready to start with our geo success and geo error functions. Okay, let's start in reverse order and first define the geo error function. And this error will receive an error object, which is what happens when you have an error. And we'll define an error message. And inside here for the error message, we'll get the error object dot message. But I'm going to use a ternary statement again. So if we have an error object, we will just set that to the error object dot message, and that will be the value. Otherwise, we'll say geolocation not supported, because remember we are calling that up above as well here in case the navigator.geolocation is not supported in the browser. We call the geo error right here as well. So it could go either way. We could receive an error object here from the getCurrentPosition method, or we could just be calling geo error up here when the geolocation is not supported. And that will cover both. Now we'll call a display error function. And in this instance, it receives two parameters. And in this instance, they will be the same. That is not always the case in the application, and that's why this function exists. However, in this instance, they will be the same because essentially we want to pass along the information we get from the error object, such as user did not allow the location or something like that. And I'm going to go ahead and save this right now. For an example of this, let's go back to the functioning app in the browser that I have. Here it is. And now, if we go up to the I, and instead of choosing to allow the location, we block that location, and then we close this, it says we need to update our settings to reload the page if we want to apply that. So let's go ahead and do that. And I have a default location saved in here now of Kansas City, so that's what the app loads. But if I click the geolocation button, it says user denied geolocation. And that's what we get from that error object. And that is what happens if it says the app wants to use your location and the user denies that. So here we'll allow it once again. It'll ask us to reload. And now I'll hit the geolocation button and we get the latitude and longitude for the Kansas City area. So let's go back to the code, and now we need to define a display error function that is helping this geo error function. And this display error function can go back into the DOM functions file. So let's click on DOM functions and we'll start defining our display error, and we'll start with export again, and then const display error. And here this is going to receive a header message, and also it's going to receive a screen reader message. And it's an arrow function. And inside this, we are going to call two separate helper functions because they can be used in other places throughout the application as well. So I'm going to name them rather long names, but it will be specific and say exactly what they do. So one is update weather location header, and it'll receive the header message. And then the other is update the screen reader confirmation, and it'll receive the screen reader message. Now these helper functions won't be big at all, but they will be handy and useful to be called in other places throughout the application as well. So we're not repeating ourselves again, and we can just call these functions. So right underneath the display error function, we'll add these helper functions, and we'll start with the first one, and it will be const, and I'll just paste in the name, which is update weather location header. And this is going to receive a message for the header. And now we need to grab the header, so I'll define our h1, and that will be document.getElementById. And it has a longer ID. If you remember, it's current forecast 2 underscores location. And now that we have our h1, we can just set h1 text content equal to message. And that finishes that function. Let's move on down and create the next one, const, and I'm going to once again paste this update screen reader confirmation. It will also receive a message parameter. And inside here, we need to select where we want it to go. So we'll have document.getElementById again. And this is our confirmation. And if you remember inside the HTML, this is where we set the paragraph to assertive. We're hiding it off the screen, but it will make an announcement for the screen reader. We'll set the text content equal to message. Okay, now these are helpers and they do not need exported, but we do need to take the display error function and we're exporting it, and so it will be imported into the main.js file. So up here after add spinner, we can add display error and save. And now we have 2 functions being imported from our DOM functions module. Back in the main.js file, we are ready to create the geosuccess function. And this geosuccess callback from the getCurrentPosition method here receives a position object if it's successful. So now we need to be ready for that, and we'll pass in the position as the parameter. And now inside here, we're going to define our own object that can hold all the information we want. So I'm going to call this my coords for coordinates object, and have this equal an object that has the latitude, and that will equal position.coords.latitude, and then a comma because we're creating an object, and the longitude will equal position.coords.longitude, and then a name, and I'm going to create a template literal string here. I'm going to have lat and a colon, and now we'll put in the position.coords.latitude, and after that we'll give it a space, and we'll pass in long, and then we'll have position.coords.longitude. And that will end the object we're creating. After that, we need to call a couple of functions. And the first one will be to set the location object. And let me go ahead and just put in a note for that, set location object. And the next one will be where all of our buttons eventually intersect except the save location button. All the other actions, including the search, will eventually end here. And this is an update data and display. So a small procedural function that will call the update to the data and then call the update to the display. And that pretty much ends the process for each action. So the application displays the weather as we want it to. So now that we've noted both of those, Let's go ahead and start that setLocationObject function, and we pass in the current location that we defined from our class. That's our current location object, or the state of the application as far as the location is concerned. And then we also have our coordinates object that we just got back from the geosuccess, and we put those in. So now we'll need to define this setLocationObject function, but it's not going to be in a DOM functions file. It's going to be in a data functions file. So let's highlight the JS folder, create a data functions JS file, and now we can create this set object location inside the data functions file. We'll click the data functions file, and at the very top we'll type export const, and I'll just paste in that set object or set location object, pardon me, and it will receive a location object and a chords object. The chords are what we received from the geolocation of the browser, and the location object is what we created with our current location class. Now we need to deconstruct our chords object. So we'll start with const, and then we want to define a lat, a lon, a name, and a unit if it exists. And then that will be equal to the chords object, and that is deconstructing an object that we passed in. And so now we have all of these variables, and we can call the location object methods, and we'll set the lat to lat, location object again, and we'll set the lon to lon, and again, and here we'll set the name to name. And then if we receive a unit, so if it exists or if it's not false, we'll set this to set unit, and we'll pass in the unit. Now let's go ahead and save that. So now let's go back to the main.js file and import that function. So we'll start once again at the top, the import, and now we can name the set location object function. And then we'll say from, and now it will be ./datafunctions.js. And now we have imported our set location object. Let's test out our location, and let's scroll down to the geosuccess. And after we set the location object, let's just log to the console our current object that we have our location stored in, and we'll save that. Now let's go to the browser, and instead of the functioning one we have, let's go over here to the other one. And remember, we can go to the sensors and change our location. So I'll click the three dots up here in DevTools, go to More Tools, and choose Sensors, and you can see our Kansas City location here of latitude and longitude provided. And with that provided, let's go ahead and try our button. I believe we don't need to reload it, but I'm going to. And now let's see if our button works and if we can log our current location. Yes, we did. Might need just a little more room to read that location here. I'll drag the sensor down a little bit. There it all is. And so we have our full latitude and longitude, and then we got the latitude and longitude set and the units as well. Okay, let's finish off our geosuccess function with the update data and display function that will be called. And it will be update data and display, just as it says, and we'll pass in the current location object. So underneath, we can start defining that object. I'll scroll just a little bit to give us some room. We'll say const update data and display. And just by the name, you can tell this function is more procedural. It's doing two things instead of really obeying that single responsibility principle that I like to. But in this instance, it needs to do both of these things after getting the data, then it is ready to call the update to the display. So it's kind of like a router or a controller, if you will. So here I'm going to define weather JSON, and we'll call await. You see it's an async function. And this will be a function we call from a serverless function eventually, but we'll create it without serverless at first. So get weather from chords, and we'll pass in that location object. And then we'll also say if we have weather JSON, if we get it from our get weather from chords, we'll call an update display, not both, just display. See if I can create that and come back. There we go. And it will receive the weather JSON and the location object. But for now, I want to comment both of these out, and we'll just end up at this function from all of our other buttons before we go ahead and work on getting the weather from the API or creating the display update. Now that we've completed the process for the geolocation button all the way to the update data and display function, let's go back and do the process for the home button. So it would be the next one here in our add listeners section. So we need to define our home button. We'll set that equal to document.getElementById, and the ID is home. From there, we'll use the home button, and then we'll add an event listener, and we'll once again listen for click. And after this, we'll call load weather, which is the same function that we want to call immediately when the application loads. So we can also call load weather right here at the end of the init app. We'll save that, and we'll scroll down to start the load weather. Let's put it right under the geo success function, as the update data and display is the ultimate end function for all of these processes. So here we'll start with the load weather function, and it will receive an event. And now the first thing we want to do in the load weather function is look for a saved location. Have we already saved our location or a favorite location? And if we have, we want to use that location to get the weather. So we'll start with const saved location, and we'll set this equal to a function called getHomeLocation. Now we haven't created that yet, and we will create this inside the data functions because it is working with saved data. Let's head to the data functions file, and underneath our export const set location object up here, let's go ahead and create this one. And so we'll say export const get home location, no parameters to receive. And this will be pulling the home location from local storage. So all we have to do is return local storage.getItem, and we'll look for default weather location. And we can save that, and I'll just copy this get home location. Let's go back to the main.js file, quickly scroll up, and we need to import this from the data functions file. So now we have our get home location imported at the top, and we'll scroll back down to the load weather. And after attempting to get our saved location, we need to add something to catch if we do not have a saved location. So we'll say if, and an exclamation mark with saved location means if that is false, if we do not have it, and there was no event passed in, then we'll return get geoweather. So this is the default for when the app loads, and possibly the first time it would load. It should definitely reach this point because no saved location would exist and no button was clicked, so there was no event passed in like a click event. So then it's just going to return the geolocation weather if the geolocation is supported, of course. And now we have some other possibilities as well. So let's also say if no saved location, and now we did get an event that is the type click, so now we know the button has been clicked, and there is no saved location, but we're loading the weather from a button that would expect a saved location. And in this case, then we want to display an error, and we've already created this function. Remember, it receives two parameters. And let's put the first parameter on its own line, and we'll say no home location saved. And then the second line, and remember the second line is for the screen reader, we'll say sorry, please save your home location first. The screen reader messages are a little more verbose. Okay, then after that, we can still have an else to this if statement, and it'll actually be an else if. And now, if we do have a saved location and there was no event, this means the app is loading and a location has been saved in the past, then we'll call a function that says display home location weather, and we'll pass in the saved location. And now we'll have one more, and that will be an else. And in this instance, we'll grab the home icon, document query selector, and that will be .fa-home. And then we'll add a spinner, animate that home icon, and then we'll display home location weather and pass in the saved location. The difference between the else if and the else is this is when the app has loaded with a saved location, but no button was clicked because it's just because the app loaded. And the else is actually when the button was clicked, so we add the spinner to the button and then we display the weather. So let's save that. And we clearly have a function to define here. We've defined get home location, but we haven't defined display home location weather. So now directly under our load weather function, let's define our display home location weather function. So we'll have const display home location weather. We'll pass in home location. And now inside this display home location weather function, let's check the type of, because this should be the string that we're getting back from the local storage. So we're checking the type of the parameter home. And so now if it is a string, which is what we expect, we want to define our location JSON and set that equal to JSON parse. We need to parse the string coming out of the local storage. And now that we have that, we can create an object. And this will be a, let's call it my chords object. There we go. And this will be a lot like we did before for the set locations object, because that's what we will be calling after this, which we've already created. So here we have lat, but now this can just be location json.lat. Lawn be the same way, and a name, and we'll have location json.name and unit. Okay, now that we've created our my chords object here, we can call our function, which is set location object. We've already defined, and we need to pass in the current location object that is from our class at the top and the my chords object that we just made. And then eventually we get to update data and display again and pass in the current location object. Okay, this would be a good time to test things out just to see if we're getting the data we expect to. And we could have done that after we finished the first button as well, but we have finished the pathway to update data and display for at least the first two buttons now. So let's just go into this function and let's log the location object that it receives, and let's make sure everything is expected up to this point. So I'll save this, and we'll come back to our test app, and I'll clear that out, and let's go ahead and open up our DevTools. I click the three dots here at the top. I should walk you through that. Click the three dots at the top of DevTools, go to More Tools, then go to Sensors, and let's pick like Kansas City here, or let's say Tokyo. And now let's go ahead and click our button, and it matches up. We've got latitude and longitude that it shows down here, and it shows the latitude and longitude up here as well. Let's go ahead and pick another one. Let's go to Kansas City, 3909, and we'll click our home button, and as expected, we didn't have a home location saved, so it says no home location saved. And it actually doesn't update our latitude and longitude here from the home button yet, because if you remember the logic here is if there's no saved location and the event type is click, we just get the error display where it says no home location saved. And that is exactly what happens right back here in our test. But we know everything's working as it should so far. So now we're ready to go back and define the next button. So let's scroll to the top, and the next event listener we want is on the Save button, which will be the one button that does not end up at the display data and save data function that we had before, update data and display. So here we have const save button equals document.getElementById, and this element is save location. And now we'll take the save button and we'll add an event listener. We'll listen for the click, and with this one we'll call the save location function. Okay, let's scroll down underneath the last function we created to create the save location function. Here we go, const save location, and this has no parameters, it's an arrow function. Okay, and we'll start out with if the current location dot get lat and current location status get lon, and remember this is from the object that we defined at the very top there from our class. So if we have a latitude and longitude in this current location object, then we're going to take the following actions. And we'll define our save icon. And now we need to get it, so we'll use document.querySelector, and we'll get .fa-save, which is the save icon, and we'll add a spinner. And after that, we're going to define a location object again. So we'll have const location equals, and now we'll have name equals current location dot get name. And whoops, not a semicolon, we need a comma there. And the lat is going to equal current location dot get lat. Lon would be the same pattern here, current location dot get lon. And then unit, dot get unit. And now that we've created our location object, we can store it in our local storage, because that's what we're doing here, is saving our location. So next time we come back to the app, we can still have this saved. We'll name this again default weather location, same place we were looking for a saved location before. And now we need to use json.stringify and pass in our location object. And after that, we want to update the screen reader confirmation. And if you remember, we already defined that, but I don't believe we've imported that yet. So here we want to have update screen reader confirmation, and a template literal string where we say saved. And now we'll pass in the current location object and get the name as our variable in the template. We're just calling the method right there as home location. And so this would be announced to the screen reader. From there, we'll stop that and save. And we finished our function. You can see I'm using prettier, and it sometimes does a line break or wraps things differently. I didn't do that. It did it automatically when I saved the file. But this update screen reader confirmation, I don't believe has been imported yet. It should be over here in our DOM functions. And yep, update screen reader confirmation is right here. We don't have an export there, I don't believe, but let's make sure it's the same one. Update screen reader confirmation. Yes, update screen reader confirmation. So let's go ahead and add the export here. Save the DOM functions file. Go back to the top. And under DOM functions, so we have our add spinner and display error, let's go ahead and add the update screen reader confirmation. Now I bet Prettier wraps this line when I save now. And yes, it broke each function onto its own line, which is how I like to do it as well. So you have your import, and then you can see the curly braces start. And I'm also using bracket pair colorizer, or maybe it's bracket pair colorizer 2. And it draws this line between the colored brackets, which is nice and easy to see. So this import statement spans several lines, right now from line 2 to line 6, and imports from the DOM function. Let's go back to the browser and actually test out our save button now as well. So here we've got this pulled up, and under sensors, let's choose something different. Let's go to San Francisco. And we can check the location here. And yes, we've got different latitude and longitude in here for San Francisco. Let's go ahead and go to the application. I need to bring this over just a little bit. Let's expand this window right now. And then I can pull the tools over. If we go to the application tab in DevTools, there we'll have storage. I'm going to close this right now. Local storage. And we have some information in here. But let's go ahead, and I don't think any of these are related to the current. No, that's a to-do list and a map box and different things. Let's go ahead and store our current location, and that's what our save button should do. And yes, now we have a default, I'll drag this some more, default weather location right here. And if we highlight this and then look below, we can see what it stored. And it stored our San Francisco latitude and longitude that we suggested from the sensors, or we set with the sensor tab. And so everything is as we expected there. Now let's see if we can load the home location. So I want to go back to the console to make sure we don't get any errors here. Bring this back over. I'll click home, and we got our San Francisco location. That is great. All right, we're down to our last two buttons, the unit preference, where we toggle the units, and just the refresh button that refreshes the current weather for our current location. So let's go back to the main.js file, and we're in our init app section here, and we can knock out both of these buttons quickly. So let's start with the unit button. We'll say const unit button equals, we'll use document.get element by ID. We'll pass in unit, and then we'll use the unit button to add an event listener. Once again, listening for a click on the button, and then we'll call the set unit pref function. But before we go down and define that, let's go ahead and do the refresh button, and then we'll define both of the functions we need at the same time. So here we'll define refresh button. We'll set that equal to document.get element by ID, and we'll pass in refresh, which was the ID for that one, and then we'll say refresh button dot add event listener, listen for the click, and now we'll call a function called refresh weather. Okay, with both of those event listeners defined, we're ready to scroll down and define those functions. So we'll scroll down to, once again, right above the update data and display function. We'll start const, let's set unit pref, there we go. No parameters to receive. Let's define our unit icon. This will be equal to document query selector. And here this icon is .fa chart-bar. And then, as you might expect, after we've done this a few times, we'll add a spinner and pass in the unit icon. And then we'll use our current location object and call the toggle unit method. And so when we click the button, if it's set to imperial, it will just toggle over to metric or vice versa. And then we'll call our update data and display function and pass in that current location object. And that is the end of that function. Okay, the next one for refreshing weather. Refresh weather. Once again, no parameter. And then we need to do the same thing we did up here for the spinner. So let me just copy that and change out some of the details. We'll call this refresh icon. And here we need to get a different icon selected, and that is .fa-sync-alt. And that takes care of the spinner. And after that, we just call update data and display again with the current location, so it will refresh all of the weather data. And save both of those, and we've completed all 5 button paths to the update data and display function. Let's scroll back up to our init app. And here we need to add one more event listener because we have all 5 buttons, but we have not handled the search box yet. And we could search for locations as well. So here we'll define a variable called location entry. And from there we'll go document.getElementById. But now we're not looking for the button or even the search button in the search box. We want the entire form. So here we have search bar, 2 underscores, and form. And what we will listen for isn't a button click, but it's actually the submit event. So we have add event listener. And here we'll listen for submit. And that way, when a user presses enter, they'll submit the form, which is the default, especially when there's just the one button and one text input. But also, if they click the button in the search box, this will also trigger the submit event. So either way, it would trigger the submit event, and that is why we do this instead of a button click, because we want the enter button to also work, as users would expect that. And then we're going to call a submit new location function. Once again, we'll scroll down to where we're just above the update data and display, and we'll start our function. Okay, we'll start with const and then submit new location. And now this will be an async function. And we'll pass in an event. And from here we need to call event.preventDefault first. And then we'll define a text variable. And we'll have that equal to document getElementById, and we'll get the text from the search. So that is the value. Oops, not a function there. It's just the value. There we go. Helping me too much. Just the value of the text. From there, we'll define the entry text, and there we need to call a function called clean text, and we'll pass in the text. And so now we'll be working with the entry text, but let's define this clean text function before we go any further. Well, maybe one more line. We'll go ahead and add one more line and we'll say if there is no entry text, and we can say that by checking the length. So if the length is false, which would be equal to 0, as 0 equals false, then we can just return and this function will go no further. So this is a good place to stop and define the clean text function. Let's go to our data functions.js and we'll create a function here that we'll export and call it const clean text. We'll pass in the text parameter. And what we're going to do in this function is just clean up the text entry. We're going to look for spaces in front of and after the text entry that we don't need. We're also going to look for 2 or more spaces in a row that are not needed. So let's define a regex, and we'll set that equal to slash space, curly brace, 2, meaning 2 or more in a row, and then another slash, and then G for global. And so this is looking for 2 or more spaces in a row. And then we'll define our entry text. We'll set that equal to text.replace all, and then we pass in our regex, and then we'll replace the 2 or more spaces with 1 space. But that only handles what's in between. So we also need to call trim, which will trim the front and the end of the string. So now we have handled 2 or more spaces within the string and extra space before or after the string. And then we can return the entry text. I'll save that, and remember now we're in data functions and we'll need to import our clean text function into the main.js file. So although we're down here in the submit new location, let's come up to the top, and this is from data functions. Had nothing to do with the DOM, it's just handling data. And we've got 3 functions, so now when I save prettier may wrap this line as well. And yes, it broke them into separate lines. And that's fine, so let's scroll back and continue working on our submit new location function. Now that we've removed extra spaces, which could also result in the entry text having a length of 0 if only a few spaces were added before enter was pressed or the button was clicked, that takes care of all of that. So now we can go ahead and change our button icon and animate it again. So we'll call location, or we'll define location icon. That will be equal to document.query selector. And now we're looking for .fa-search, which is the icon on that button, and we'll add the spinner there. And after we've added the spinner, we're actually going to call a async function, and this is already an async function, and that's why we needed it to be, because we're going to call a coordinate function. So I'm going to define chords data, have this equal to await get chords from API. And now we'll pass in the entry text, what we're searching for, and we'll also pass in the unit. So we need to call the getUnit method from our current location object. Now before we complete this function, we'll need to take a look at the API and what we expect to get back from passing in entry text to the API. And then we will also be creating functions that work with the API. In the meantime, we just know that we're going to work with API data here. And then we can also do something if we do not get the data, and that is going to be an if-else essentially. So if we have the data, if, and here, I guess I could just put the first part of that if statement because I really want to get into looking at the API data before I get too far in, but it's chords data.code. So we're looking for an HTTP method that indicates success, or a response actually that indicates success, and that would be 200. So here's our success. But then if we do not have success, we have an else. And here we're going to display an error, but this is a different error than we've had before. This is a display API error, and now we'll pass in the chords data. And we'll do that so we can display the actual error that we get back from the API. Now, besides working with the API data, I guess I should put this maybe inside of here. Kind of goes hand in hand with the success of that request. At the end of working with that data, we'll once again call our setLocation object function. We'll pass in the current loc, and we're going to pass in a myChords object that we're going to create. And then we will also call the update data and display function and pass in that current location again. So before we look at the API for this possible information coming back from the await function, let's go ahead and just define the myChords data object here. And so we'll say const myChords object equals, and I'll just set it to an empty object right now. And we'll save that, and now we've got a couple of functions we need to define. One is the one that gets information from the API when submitted text is entered, and the other is the display API error. And so let's go in reverse order and work with the display API error first. Let's go to our DOM functions, and we'll look for the display error. Here it is on line 12. Just underneath the display error, let's define export const display API error. And this will receive, let's call it a status code. And I'm just thinking along the lines of we got a status code that is not a 200 that we were looking for. The first thing we're going to do is define a variable called proper message. And we're going to call a helper function called toProperCase. And from here we'll get the status code dot message. Now we'll call a function we've already defined, and that is update weather location header, and we'll pass in that proper message. And then we'll call the update screen reader confirmation. Whoa, there we go. Update screen reader confirmation, and we'll pass in the proper message. And then instead of just passing in the proper message, actually, let's go ahead and make a template literal where we'll pass in proper message with a period after, and then we can say, please try again. Just a little bit more verbose than before. And then after that, if we wanted, this would be a place for us to debug anything, and we could put in a console.error, or you could write to an error log or anything like that. But I'm not going to do that here. So we'll just do both of those, and we'll save that. Now, just underneath this function, let's go ahead and define that helper function of toProperCase. So here's our toProperCase function, and this could come in handy in a variety of programs, not just this program, much like our clean text did where we removed extra spaces. This will just set words to proper case. So here we have const words, and we're going to set this equal to the text we pass in, and then split the text based on the spaces between the words. And now we'll have proper words equals words, which is an array of the words that were in the text. And now we'll use the map function. It's a higher order function, and we'll pass in word for each word, essentially is what's happening here. But map creates a new array, so proper words will be a new array, and it will be filled with the results of this. So we'll have word dot character at 0. We'll set to uppercase, and then we'll concatenate here word dot slice 1. And that completes that. And now that will do that for each word. And now we can return proper words dot join, and we'll put a space between the words again. So now we have set each word to proper case. Now before I forget, let's take display API error, go back to main.js, scroll up to the top, and from the DOM functions, we need to add it. I'm going to add it right after the display error function. And so now we've added our display API error function, and I will save that. Now it's really time to look at the API, except there's one other function we need to handle first that does not work directly with the API, and that is here in the setup. And I want to use a function that I'm going to call set placeholder text. This function is based on what I would call a JavaScript media query, and it affects what is appearing in the app. Matter of fact, the placeholder text inside the search box. So let's save this, and we'll need to go back to the DOM functions and define this set placeholder text. Since it's one of the very first functions called, let's put it right at the top. So we'll start with export const and set placeholder text. Now I'll leave a space before the add spinner. Okay, inside this function, and I did make a video about this that I could show here with a link at the top right now, but we're going to look at the width of the page. First we have to grab the input, so we'll say document.getElementById, and we'll get the search bar 2_ text, which is the input. And now we'll look at the width of the window, and based on that width, we'll set the placeholder text. This is something you can't do with CSS, but you can do it with JavaScript. And so we'll call window inner width, or we'll look at the window inner width property. And if it's less than 400, I'll use a ternary statement here. And if it's less than 400, we'll put input.placeholder equals city, state, country. Otherwise, we'll have input.placeholder equals city, state, country, or zip code. So on screens that are less than 400 pixels wide, essentially, there's not room for all of that in the text box. Otherwise, there is. Now, this is a ternary statement, and as soon as I save the file, it will wrap because I'm using the prettier extension, and you'll see how it's formatted. So I save, and well, I need to scroll back to the left, and you can see this ternary statement is now broken into 3 lines, which looks great and it's easy to read, but you don't have to include the line breaks yourself if you're using the prettier Visual Studio Code extension. With our function defined, I'll copy the name and we'll go back to the main.js. We're bringing it in from the DOM functions. So at the top, DOM functions, I'm going to add it as the very first function added because it is really the first function called before these others, as the init app goes. And we have it here. And so our setup is finished. We have our load weather function as well, and that's finished. So now we're ready to look at the API and finish out our submit new location function that we began down here, but we have a little more work to do. And this function, get chords from API, is not yet defined. Let's go to the browser. And in the browser, we'll pull up our sample app here, but I'm going to expand the browser now, and we'll visit the weather API site, which is openweathermap.org/API. And this is a great place to sign up for free access to this weather data. And they have several different APIs with documentation for each one. We're going to actually use 2 of their endpoints. And there's a reason for this. The reason is we won't always have the latitude and longitude right away. We want users to be able to enter in text like New York or a zip code like 10001 and then get the data requested back. So the first API we will use is this current weather data API. It allows a zip code or a city name or even a country name or a state name or any location like that to be entered, and you get data back. The other one we'll use is this one call API. And this is great, but you have to have the latitude and longitude for the one call API. The other reason we'll use the one call API is because it contains the 6-day forecast that we want to use in our component that shows at the bottom of the app that shows the extended forecast. And the current weather data API does not have that. It just has the current weather data. Also, we're kind of piecing this together from the different free endpoints available rather than if we had a paid subscription here that might deliver everything we needed from one endpoint, and they might provide that. So we have to structure our requests. They will be GET requests, and that means our parameters will be passed in an encoded URL to their APIs as their documentation indicates, and then we will get structured JSON data back to work with. So if you haven't yet, sign up for a free account at openweathermap.org/API. And you can see I've got one. It says Dave Weather app up here. And you will get a weather map API key. And now, of course, this is a free account, so you don't have to be too worried about hiding that API key. If you use it too much, they just shut it off for a while. However, it's good practice to hide your API keys, and we will be doing that later in this tutorial with serverless functions. Right now, just get signed up, and then I'm going to take you through the structure of these requests. And to do that, I'm actually going to open up the Firefox developer browser. I like to look at JSON data in it more so than I do Chrome. And so here is JSON data from a request to that current weather conditions API. You can see it doesn't contain the extended forecast or anything, but let's look at the URL that has been structured. You can see I have, after the endpoint that ends in weather, I have a question mark, which usually means parameters are coming, and the first parameter is a zip. That's the zip code, so that is passed in, and then use an ampersand to connect the next parameter, and that's units, and that is set to imperial, and then the app ID is the API key that I'm using. And of course, I'll delete that key after this tutorial, but I can show you this key and use it during the tutorial. And so that is one example of what that current weather API endpoint will accept, but it will also accept names of locations. So I will copy and paste in an example of that as well. And the URL has to be encoded. So if there is a space in a name like Los Angeles or New York, that needs to be handled properly, and we will encode the URL. And you can see, as you've probably seen before, there's a %20 between Los and Angeles there, and that means that URL has been encoded. And now we got results back right away, and we get the latitude and longitude, and that's really what we want to get from this endpoint. Although there is other information, we'll get that from the other API endpoint. We just really need the latitude and longitude to complete the request with the other endpoint. And this is an endpoint that will actually translate a search like Los Angeles, New York, or anywhere in the world really, into latitude and longitude coordinates for us. So let's look at the difference in the second URL. And as I highlight it, you can see the first parameter is no longer zip equals, it's Q, and Q usually stands for query, but Q equals, and then there's Los Angeles. Notice it put a space in here, but the actual URL had a %20 where the space was, so we will have to encode our URLs. Everything else, the units parameter and the app ID parameter is the same. So we're either passing in text with the Q equals, or we're passing in what we think is a zip code with the zip equals. And so now we can go back and create that function that will interact with this endpoint of the API to give us the lat and longitude coordinates for whatever is searched for in that search text box. Let's go back to Visual Studio Code. And let's take a look at this get chords from API we're calling. We're passing in some text that has been searched for, and we're passing in the units that we want to get back from the API as well. And so now we need to define this get chords from API, and you can already tell it's going to be an async function because we're awaiting it right here. So get chords from API, and this will be in the data functions because it is purely a data request and it is not doing anything with the DOM. I'll click on Data Functions, and I'm going to scroll down to right here under Get Home Location, and we'll start defining the function. So we'll say export const, and this is get chords from API, and it equals an async function, and it does receive entry text that will be searched for, and it also receives units without the E. There we go. Get an arrow function going. Okay, the first thing in this function will be a regex. And I should mention we're going to change this function eventually because this will be handled by a serverless function, but I want to define it and show you how it works inside of the application first. So we'll define a regex here, and we want this regex to look for entries that start and end with numbers. And we'll assume those are zip codes that have been entered. And so after we define our regex, let's define our flag. And our flag is either going to be the zip equals or the q equals in our URL. So we'll test the regex, regex.test, and then we'll pass in the entry text. And if it starts and ends with a number, so the regex is true, then we'll set the flag to zip. Otherwise, we'll set it to Q. And so that's a ternary statement that is testing that regex. And then we're going to define our URL. Now, I'm going to paste the URL in here, and then we can go over it. And this is from the API. I'm going to press Alt-Z to wrap what extends beyond the screen. But let's look at this. Here's the endpoint, api.openweathermap.org/data/2.5/weather. All of that's the endpoint before we add anything. Then the question mark, and our first parameter is actually what we defined as our flag. So we're either going to search for zip or a query that's going to search for a name of something. And then we pass in our entry text. This is all a template literal string. And then the units parameter, and we'll pass in the units. And then finally, the weather API key. And we need to define that, and we will pass that in as well. So let's go ahead and define this weather API key. And just to get us by temporarily, let's define it at the top of the file as a constant. And I will paste that weather API key in. There we go. Save that, and so now we have our constant weather API key defined as well, so we can use it in another function we make here in just a little bit. And so now we have built the URL, and we have inserted in these variables into our template literal string that is the URL. After building the URL, we still have some work to do because we need to encode the URL. So let's call this encoded URL. And the reason we need to encode it is you might have a word or a term that has a space or two in there, like San Juan, New York, Los Angeles, any of those. Now, encode URI is built in to JavaScript. It's not a function we have to define. And we can pass that URL in, and now the spaces will be turned into %20s. The minus sign in a latitude or longitude will be turned into %2D, and so on. So it encodes the URL so it will work on the web through the request. Now we need a try-catch block, because here's where we will connect to and get data from the API. So we'll define our data stream that we expect to get back. That's going to equal to await fetch encoded URL. And if you're not familiar with async, await, and fetch, I do have a video tutorial on that that gives several examples and walks you through step by step, and I can link to that above right now. Okay, after we await that data stream, now we'll define JSON data, and we'll await the data stream to be converted to JSON with the JSON method. And after that, we'll return that JSON data. But this is a try-catch block, so we still need to finish with the catch. And for now, we'll just log the error to the console, and we'll log the full error stack. Okay, with this function complete, let's go ahead and add one extra line with a console log just to make sure we're getting the JSON data back from the API that we expect to. We'll take the get chords from API function and copy that name. I'm going to save this file. We'll go back to the main functions, and here at the top of the file I'm going to import in this function, and that is the get chords from API function. And we'll scroll down to our submit new location function. Here we are. I'm going to go ahead and save the file, and this is where we'll work with the data. But this is something to think about. I actually put in this chords data.code, but if chords data doesn't exist, that will cause an error right away. So what we want to do is start out with an if statement just to see if the chords data exists at all. And if it doesn't exist, then we can do something else. So let's tab all of this in, and now underneath we'll close out that outer if statement, and now we have a nested if-else statement. And here we'll have an else, and we can just display the error. We'll call that other function, and remember it receives two messages, one for the header on the page and one for the screen reader to announce, and we'll just say connection error, and that's because we will not have received any information in that chords data at all from the API. But then if we have received information, even if it's error information, we can go inside here and we can either display the error that we received back, or we can go ahead and work with that data. Let's save this much, and let's test out our app in Chrome, and let's see if we log to the console over here when we enter in something like New York. And we do. We get those, get that information from the data functions where we're logging the JSON, and then we also get this way down where we were logging the current location. And notice some of this is undefined, but that is okay because we currently are setting this my chords object here to an empty object, and so I would expect some of that to be undefined. So back here in Chrome, what we got here is exactly what we hope to get when we searched for New York, or we could search for a zip code. Let's go ahead and enter in a zip code like the New York zip code 10001, one of many zip codes for New York, I believe. And yes, it works just as well, and we get information back. So we're going to take some of that information and work with it. Let's do that right now to finish out this function. We'll delete the work with API data comment, and we'll just define this my chords object. And here we'll be working with that data that we get back. So we have to know where we're getting the data from, or what part that we've received. The first will be lat, or for latitude. And now what we're receiving is chords data, so we'll refer to it as we have been up here. But then we need to start referring to parts of the object. And we'll say dot chord, because that's where the coordinates are stored. Dot lat is the latitude. The longitude is the same, except it's dot long. And then the name. And for the name, we're going to use a ternary statement. So we're going to check the country name, and this is chords data.sys.country. And we can actually look back to Firefox, and we can see all of this. So here was our chord.lat or chord.lon, and then further down is sys. So we have sys.country is what we're going to be looking at. Now, back in Visual Studio Code, we're saying if sys.country is true, if it exists, then we'll put in our ternary operator here and say, okay, if it's true, do this. Let's create a template literal, and we'll use the chords data.name, and then we'll put a comma, and we'll put in chords data.sys.country. So here we're doing a city name, comma, country. if the country exists. But if we did not receive any country data, we'll just say chords data.name. Now, no semicolon at the end of this. This is as part of an object. And when I save this, once again, Prettier will format it differently. Scroll back over here to the left, and you can see the ternary statement is now on 3 lines. It's part of the object. So here is what we're checking to see if the country exists. If it does exist, do what's on the line of the question mark. If it doesn't exist, do what's on the line of the colon. And that finishes out this function for submit new location. So we'll save that, and we're creating this chords object, and then we're submitting that chords object to set location object, which is something we've done before. And then we call update data and display, and that's the function that we have not gone any further with yet, and really it has no more to the body than what we put in it to begin with. We just need to define get weather from chords, which is different than get chords from the API. Now that we have the coordinates, we can get the weather information we want, including the extended forecast. And then after that, of course, if we have that weather JSON data and have received it, we update the display with it. Okay, we need to define get weather from chords, clearly a data function. So I'll copy this name, and we'll go to our data function file. And right after get home location and before get chords from API, let's go ahead and define this function. Export const get weather from chords. It will be an async function, and we will be replacing this function with some serverless function, or serverless functionality. However, right now we need to define it as is to just have it work in the browser, and then we'll change that. So we'll define the lat first as a location object that is passed in, and then we'll call the get lat. And then we'll define longitude, do the same thing. And then we'll define units. And there we go, get unit. And now we'll define the URL. And once again, I'm going to paste this in. And now it is wrapped, and we can discuss the breakdown of this URL. It's the GET request going to the API. So here's the endpoint all the way through to one call. Notice how it doesn't end in weather like the other endpoint did that we got the latitude and longitude from. This is the one call API, and it requires a latitude and a longitude to be received as parameters. And then we're also telling it to exclude the minutely, hourly, and alerts that it could provide. However, we will still get the daily weather from it. The units will still be set, and we'll still pass in our API key. Let's go to Firefox, and I'll paste an example of this URL in, and you can see it provides a lot more data. And this is what we are requesting, so we're getting that daily data as well. And now we have all the information we need when we get this information back from the API. Back to Visual Studio Code. We can finish out the function now that we've defined the URL. We need to provide a try. And by the way, we don't need to encode this URL as we're putting in the lat and longitude that we received programmatically. So we know what that will be. The units we're also receiving programmatically. So there is no direct user input that requires this to be encoded. Okay, we have a const, and now we'll define the stream. I'll call it weather stream for the data that we get back. And we'll await a fetch for the URL. And then we'll call weather JSON. Actually, we'll define weather JSON and await the weather stream to be converted with the JSON method. And then we're going to return this weather JSON. But as part of a try-catch block, we also need to define the catch. We'll grab the error, and if we have an error for now, we'll just console log the error with an error message. And once again, we will be replacing this with the serverless function, but this should function well enough right here in the browser as is. The serverless function will allow us to hide the API key, and it will not be visible in our front-end code. Now that we've completed this function, we need to import it, get weather from chords into the main.js. We scroll up to the top where our imports are from the data functions file. We'll put it right after the get home location. And save our file. Now let's go down to our update data and display function. Let's remove this console log statement. But now that we should have weather JSON, let's go ahead and put a console log statement here, and instead of the location object, we'll put in the weather JSON. And now let's just comment out this last line because we don't have the update display function yet. And now let's see if we can log that weather JSON to the console. So let's head to Chrome. And now we're ready to check the console for the weather JSON. And that could come from any of these. If you remember, the endpoint eventually, not the endpoint for the API, but as we progress, whether we request the latitude and longitude with this button, our home location weather with this button, even if we change the units, it grabs the weather once again, or if we just refresh the weather. So 4 out of these 5 buttons should end up at the update data and display function. I'll press the location button. And there we go. We have got the weather as expected. And it doesn't look like I can scroll right now, or I need to go ahead and expand to scroll some more. There we go. There's lots of information. Here's the current and the daily, which is exactly what we wanted. Now we can provide that 6-day forecast. We actually get more than 6 days, but that's all I wanted to provide and fit nicely on the page. Now that we're grabbing all of the data we need, let's go back to Visual Studio Code. And what remains is to update the display. So you know we will now be creating more functions for the DOM, the document object model. Let's go to the DOM functions file and we will define our function update display. Let's put it at the bottom of what we have so far, and we'll say export const update display. It's going to receive 2 parameters, the JSON weather data that we get and the location object that we have. Okay, the first thing we'll do inside this function is call a helper function, and that is what will help fade our display that we have set with the fade in class. So just underneath this function, let's go ahead and define that fade display. Now we're not going to apply the fade display function to everything that we applied the fade in class to. We'll just do it to the weather areas, so the current conditions and the weekly forecast. And you'll see what I mean here in a second. First, let's define, we'll just call it CC for current conditions. We'll say document get element by, and we'll grab the current forecast section. And now with this section, we'll take CC and then we'll say class list, and we'll toggle the 0viz class that we set. And if you remember, that went with the fade in class. And so we'll put 0viz on to actually hide what is there. And then if it has the fade in class, we'll remove that. And if it doesn't, we'll add it. So it'll either have one or the other once again. And here we'll say fade in. So now we've toggled that on both. Now we want to do the same thing, except let's do it for the 6-day forecast. So I'll call this 6-day, and we'll change this, and over here we'll need to grab the daily forecast. We could probably make our code a little bit drier and do this programmatically, but to save the 3 lines, I just did this twice rather than figuring out the exact code to loop through and do it twice the other way. So we have 0viz and fade in being applied or not applied, and the same here. So what that means is at the beginning of the function, it'll actually hide these weather areas while we get the new data. And then at the end of the function, we'll once again call fade display, and it will do just the opposite. It will show those and they will fade back in. So we'll apply 0viz first and take away the fade in class. And then at the end, we'll take away the 0viz class and apply the fade in class. So this is truly a toggle function, and we'll use it twice here within this function that is going to cause or call, this update display will call several functions in a procedural manner here to update the display of the application. So there's the fade display function. After that, at the beginning of the function, we need to call a clear display function. So let's also define the clear display function, and it will be different than the fade display. It's not an animation at all. It's actually clearing out the old data. So here's clear display, no parameters. It will do the same thing every time. And so let's grab the current conditions. And this will be document.get element by ID. And this will be current forecast, 2 underscores, and conditions. So specifically, the area or the div within the current forecast area or the current conditions area that has the dynamic data. And then we're going to call a delete contents function that we haven't yet defined and just pass in this current conditions. And we're going to delete, that will delete everything within that div. And now we're going to do the same thing for the 6-day forecast. So we'll say document.get element by ID. We'll pass in the daily forecast, 2 underscores, and contents, because that is what's dynamically updated. And we'll call delete contents on the 6-day forecast. So that will completely clear out the container for both the 6-day and the current conditions, and it will be ready to have new data created. So let's go ahead and define the delete contents function. And this is a function you can use really in any app because you feed it an element and then it deletes everything inside that element. So you feed it a parent element to be more accurate, and we'll define a child variable. I'll take the parent element dot last element child. And now we'll say while child, and inside this while loop, we'll refer to the parent element and then use the remove child method and pass in the child. And then we'll reset the child to equal parent element dot last element child once again. So as long as there's another element, child will always equal the last element in the container that it was fed or inside the parent element, and it will continue to delete all of the elements within that parent element until there are no more elements. So let's save that, and now we have our clear display and delete contents defined. Now going back to our update display function, after we have faded in and absolutely actually hidden the areas first, cleared them out, and then we'll fade in at the end. But after we have hidden them and cleared everything out, we actually need to get the new data. So let's define this as a weather class, and we'll call get weather class. But we're going to pass in some of this JSON now. So weather JSON dot current dot weather. Now in brackets, we're referring to the first position, then dot icon. And yes, that is a fairly detailed reference to the JSON there. So let's look at that really quickly in Firefox. And we're referring to, again, the weather JSON, which is the whole thing, and then current, which is right here. And after current, we go to weather, and then there's a 0. So that is the first one. And from there, we're referring to the icon. And they Open Weather Map API provides icons, and it is telling you what one to refer to here. So it's 02D. We're getting that specific information. Okay, once we have that, we're calling this getWeather class, so we need to define that function. Let's scroll down to underneath our delete contents function, and we'll define getWeather class, and we're passing in that icon that we grabbed out of the JSON, or at least the name of the icon. And so now we'll say const first two characters, and that's going to equal the icon that we pass in, and then we're going to call the slice method. So we're grabbing the first two characters. We can tell what that does just by the name of it. And now the last character is going to equal icon.slice and 2. Now we're going to use an object lookup. We'll call this weather lookup. So const weather lookup. Let's set this equal to an object, and we'll start out with 09, and that will be snow, and then 10, that could be rain. Likewise, it looks like 11 is also rain, and this is information translated from the API documentation here. There is no 12. We'll go to 13, at least for us, snow, and then 50 will be fog. We'll save that much, and now we have our weather lookup, but now we can use that weather lookup. So let's define weather class with a let keyword, and we're not assigning a value yet. So now we'll say if weather lookup, and we'll pass in the first two characters. If that much is true, we'll say weather class equals weather lookup first two characters. And that is using our weather lookup, and we're passing in those first two characters to see what they match. After that, oh, and I can see after I saved this, Prettier has changed the code on me just a little bit. I don't know why 9 is still in quotes, but 10 through 50 is not, maybe because it starts with a 0. But this still works as is. Okay, after looking up the first two characters to see if that we have a match there, then we can say else if the last character equals D, which should stand for day if I remember correctly. We'll say weather class equals clouds, because we didn't find one of these other scenarios of weather, snow, rain, or fog. So then we know it's daytime, and we'll use the clouds because we're defining this for what we'll use as a background and colors soon. And then the else weather class would be night. So from that information and the classes they give us, we're figuring out what type of weather it has and how to adjust our display. So after we use that if, else statement, we eventually want to return the weather class that we have determined. Let's scroll back up to our update display function. And after we have determined the weather class, we want to call set background image, which is a function we'll define next, and pass in the weather class we determined. Let's scroll back down and define set background image. Start with const set background image, and it will receive the weather class we defined. Now inside this function, we're going to grab the root element, so document.document element, and that is like the HTML element. It is the absolute root of the document. And we'll say class list, and we'll add the weather class. Now we'll use a for each statement, so we'll say document.document element.classList.for each. And now we'll pass in an image, or we'll say for each image. And inside this for each higher order function, we'll use an if statement, and we'll say if the image is not equal to the weather class that we have determined, then once again refer to the root here with document.document element, and then class list dot remove the image. And so we only want the image applied to the HTML element if it matches the weather class that we have determined. And if you remember our SCSS file, we have a partial that actually had the different names of the weather, such as rain and snow, and those are the classes that are added to the root element, and of course they only remain if one of the names match the weather class. Let's scroll back up to our update display function once again, now that we've determined the background image to set. And now we're going to define screen reader weather. And this will be a statement that we build, and we're going to do that with a helper function called build screen reader weather. And for that, we'll pass in the weather JSON, and we'll also pass in that location object. We'll save that, and Prettier wrapped both of those parameters down to the next line for me, but it's still the same definition. And now we need to define this build screen reader weather. Let's once again scroll down to the bottom, and we'll start right here with const build screen reader weather, and it will receive the two parameters, weather JSON and location object. It's an arrow function, and first we'll define the location, and that will be equal to location object, and we can now call the getName method on this object. And then unit will be equal to location object dot getUnit. And now we're going to define a temp unit, and this is going to equal unit, and this is if unit equals imperial. We're going to make a ternary statement. So if unit does equal imperial, then temp unit will equal the abbreviation for Fahrenheit. Otherwise, it will equal the abbreviation for Celsius. And that we're setting temp unit with a ternary statement. And now we're going to return a template literal statement. And in this statement, we'll say weather JSON dot current dot weather 0 in brackets description. So we're getting a description of the weather, such as partly cloudy, and then we'll have and now we'll pass in the math with the round method, and now inside math with the round method, we're going to place a number. If I can spell number correctly, there we go, number, and weather JSON dot current dot temp. So we get the actual number for the temperature. After that, I want to go ahead and press Alt-Z to wrap this. It's getting a little long. After that, we're going to need a temperature kind of dot. I can't think of exactly what you call that, but it looks like this, like a degree, essentially. Maybe that does mean degree. And then we'll pass in the temp unit into our string, and then we'll pass in the location. And so this is very verbose, but here if we read this and just stop and think about it, it will be partly cloudy and 65 degrees Fahrenheit in wherever we are. And so that is a statement built to be read by a screen reader, and that's exactly what will happen up here. If we go back to our update display, and we've got our screen reader weather is equal to what we just built. And now we can call a function that we've already defined. It will be update screen reader confirmation, and we can pass in the screen reader weather. And we'll save that much. And now we're ready to update the header, which we've also defined before. So update weather location header. And here, we'll just use the location object we have and call the getName method. And so now that will be updated at the top of the app. So now let's step through what is left to update the display. First, we have the current conditions that need displayed still. And then we'll have the 6-day forecast that needs displayed. And then we want to set the focus back on the search area. So let me just put this function in right now. Set focus on search. And then we fade the display back in. So let's define the set focus on search before we get into creating the actual grid and containers that we have for the two areas of the weather. Let's scroll down to the bottom again. And here we can define const set focus on search. No parameters. We'll just say document.get element by ID search bar 2 underscores text. And that is the text input for the search. And then we'll just call the focus method. And now after the weather displays, it will be ready to receive more input immediately into the search bar if needed. Let's scroll back up to the update display and we're ready to work on the current conditions and the 6-day forecast. Let's start with the current conditions. And to do that, we want to create an array. So I'll say current conditions array equals, and I'll title this function exactly what it does, create current conditions divs. And we'll pass in the weather JSON, and we'll pass in the location object and just call the getUnit method. So we only need the unit from that passed in. And after we do that, we're ready to create this create current conditions divs. Let's scroll down. This function's just a little longer than some of our others, but it's necessary to create all the divs we need. We'll get the weather object in here as a parameter, and we'll get the unit that we passed in. And the first thing we'll do is figure out the units we're going to use. So the temp unit will be defined, and it's equal to a ternary statement. And if unit equals imperial, then the temp unit will be Fahrenheit. Otherwise, it will be Celsius. And we'll define the wind unit as well. So wind unit equals unit. And once again, if that equals imperial, whoops, there we go. It'll be mile per hour. Else, it will be m/s. And I am not exactly sure what that is, maybe meters per second. Not as familiar with the metric on my end. Okay, temp unit and wind unit defined. Now we'll define the icon. And for that, we're going to use a helper function. So we've got create main image div. So once again, it's named exactly what it does, and we'll pass in the weather object and then current weather bracket for that 0 again and get the icon. And then we'll also pass in weather object dot current dot weather bracket for the 0 and the description. Need both of those. Okay, so now we're creating this current conditions div, and we have run into another helper function of create main image. So we'll stop right here with the current conditions. We can save that and prettier wrapped that function call there. And let's go ahead and create this create main image div function. Okay, it's going to receive an icon and alt text for the image, as all images should have alt text. We'll have icon div, and we're going to call a create elem function. And as you might guess, that's going to be a helper function that we will use a lot. And we'll pass that in, and then we'll define it after we finish this. And then the icon div is going to have an ID equal to icon. And then we'll define an FA icon, which is a font awesome icon. And we're going to have another function that says translate icon to font awesome. Another long name, but it is very specific about what it does. So then we'll say fa icon dot aria hidden equals true. That's for accessibility reasons. And then fa icon dot title equals alt text. And then icon div dot append child, and then we'll pass in that font awesome icon, and we'll eventually return the icon div. And that's good, you say, except of course now we have create element and translate icon to font awesome. Well, let's go ahead and focus on the create element function, because we also need it to go ahead and complete our previous function that was creating the current conditions array. Then we'll get more concerned about the translation to font awesome later on. Okay, so underneath the create main image div, we'll define create elem for create element. Now this will receive several parameters. We'll say elem type, div class, we'll call it div class name, the text that goes in the div, and the unit. And that's about as many parameters as you want to have for a function, unless you just turn it into an object and pass in the object. Okay, const div, this will be document.create element. Oh, we need an equals there, I missed out on. Document.create element, and we'll pass in the elem type. And from there we'll have div.className equals div class name. And now we'll say if there is div text, div.text content is going to equal the div text. After that if, we'll also check to see if div class name equals temp. A little bit more specific here, we'll define a unit div. We'll have that equal to document.create element, and we'll specifically create a div. The unit div.classlist.add will have a unit class. Unit div.text content is equal to the unit that we've passed in, and then the div.append child will be called, and we'll append that unit div to the temp. And that's only if it's the temperature. After that, we want to return the div that has been created, and that is the create elem function. Fortunately, no other helper functions to create there. Document.create element is built into JavaScript, so that is good. And we can come back up to the main function we started, once again, not forgetting about our translate icon to font awesome, but coming back to the create current conditions divs, and we can start to create these divs with that create elem function that we just created. So const temp equals create elem, and we're going to pass in div, and then the class name is temp. And then we're going to pass in a template literal. This takes up a little bit of room, but math.round number, and then it's weather object.current.temp. And then we need that little degree indicator once again, and we'll put it right before the template literal ends. And that calls the full function right there, passed in everything we need. And after temp, we can define proper description and have that equal to our toProper case function that we've already created earlier. And here we'll pass in the weather object.current.weather and the bracket dot description. And once I saved that, Prettier, of course, wrapped all those parameters we had in create element, so they're on their own lines, but it's the same thing we had before. After the proper description, we'll define description. We'll set that equal to create element and div. The class list will be the abbreviation for description, and we'll pass in the proper description that we just defined. I'm going to scroll to give us just a little bit of room here. And the next one after description we'll define is feels, and this is where it says it feels like a certain temperature. So we'll have create element. This will be a div. And now we'll pass in feels as the class. And let's do another template literal string where we say feels like math.round number, and now we'll say weather object dot current dot feels underscore like, and we once again need that same degree symbol, and I'll paste it right in there. If you wonder where to get that, maybe check a Unicode website. I can't remember exactly where I got it. There's probably a command, some type of alt on the keyboard to get that as well, but I don't know exactly where to get that or exactly remembering where I got that, but I know you can find one. Or I'll have the source code, of course, also available in the description below. Once I save that, Prettier broken into separate strings as well. We've got a few more to go, so let's go const max temp equals create element div comma max temp for the class comma, and now another template literal. We'll say hi math.round, it's a number, and this will be weather object dot daily 0 dot temp dot max, and we yet again need that symbol here. Now let's define the min temp. It should be a very similar pattern. After the min temp, that would be the min temp is the class. I guess I need quotes around that, min temp. And then we'll start another template literal, but instead of hi, it says low math.round and a number. And inside here we'll have weather object and daily, brackets for 0 dot temp dot min, and we'll once again paste in that little degree symbol. And after min temp, let's go ahead and save, and those will get wrapped as well. The next one is humidity. This will equal create element, and we'll have a div, and humidity will be the class. And then we'll have a template literal that says humidity, and this will be weather object dot current dot humidity, and at the end of it, instead of the symbol we've been using, we'll have a percentage, as that's how humidity is measured. And finally we'll have wind, and that will also be equal to create element and a div and a wind class and a template literal that says wind, and then math.round number and weather object dot current dot wind underscore speed. And again, we got all of these from the API, so you just have to follow from the weather object to the current or whatever it's under and find what you're looking for. And there's the wind speed, and of course all of that's in the documentation. Then let's give this a space, and let's also put in the wind unit that we determined above, and that should finish out the wind div. And at the very end of the function now, I'll save this so it wraps as well. At the very end of the function now, we need to return all of these divs we've created, and the main image element as well. So we have the icon, which is what that was, and then a temp, a description, fields, max temp, min temp, humidity, and wind. Okay. We save that, and now we're returning our array of elements that we're ready to put into our app. Now, before we display the elements in our array, let's go ahead and take care of this translate icon to font awesome function. And this is a function that will actually translate the icons that are suggested by the Open Weather Map API to similar icons from Font Awesome. And I found that to be a little more useful. If we quickly look back at the, there we go, at the completed version, we have a Font Awesome icon up here. And you can see in the bottom we're using the icons from the Open Weather Map API, and those are okay. They have different colors. Sometimes those colors work, sometimes they don't. So I went ahead and left them here in the bottom, but I decided to use a Font Awesome icon that I could get to match the font everywhere else up here at the top. So that's what this function is about. There's our working version still. So we'll start down here and we'll say const translate icon to font awesome, and we're passing in an icon, and from there we'll define I would be the element, and we'll say document.create element, and we want an I element for icon. Then we'll define the first two characters, and we'll set that equal to icon.slice 0 and 2. We're grabbing those first two characters, and we're grabbing the last character again as well. So that's equal to icon.slice and 2. Now I'm going to use a switch statement. Many times I try to avoid a switch statement, but in this case it makes sense. So we'll say first two characters. And we have several cases to look at now. So case 01 is the first possibility. And in this case, we'll say if the last character equals D, which would be day, we're going to set I class list, which is how you apply a Font Awesome character. We'll add far and fa-sun. And there will be an else. Let me give it a little extra room here. Else I-class list dot add far again and fa-moon. So if it's not day, it's nighttime. And as is the case with any switch statement, after that you need to add a break before you can add to the next case. Here's case 02. It will be very similar, so I'm just going to copy this, paste it here, and then change out the little details we need. Once again, we look for the D there, and now instead of far, we'll change this to FAS, and then we'll use FA-cloud-sun, and this will be FA-cloud-moon. Okay, case 3, and this won't be as big, so we'll have I.classList.add FAS, and then FA-cloud. And we can just put our break right after that. I'm going to scroll again for some more room. Case 4, and this will be I.classList.add FAS again, and then FA-cloud-meatball. That's an interesting name for their icon. And break. We'll go ahead and copy this to paste for the next one. And let's back that up just a little bit. There we go. It's a 9. And out of this possibility, we'll start with FAS and then FA-cloud-rain. And now I'll copy one of these larger ones again for the next possibility and bring it back. This will be 10, and this looks for D, and then it will be FAS, FA cloud-sun-rain. And the else is FAS, FA cloud-moon-rain. Okay, now just copy a smaller one. We'll paste the smaller one in, and this will be number 11. I classless FAS, FA, and I did not name these, but it is poo storm. And I think I know what that refers to. The weather definitely would not be good if that indicates a poo storm. Okay, after 11, the next possible case is 13 that we're looking for. And that class list is FA or FAR and then FA-snowflake. Just one or two more possibilities to go. Paste in the next case, and this instead of 13 or 14 is 50. And here it will be FAS, and then it is FA-smog. And then is our default. So if none of the others apply, this is what we will use. And it will be i.classlist.add far, comma, and then fa-question-circle. And again, there might be some better font awesome icons that you could add. These are all definitely in the free version. I'm not using the pay version in any way. But these are the possibilities, and we're translating the first two characters that the Open Weather Map API gives us for their icons. We're translating those into font awesome icons. So after the full switch statement that we see started way up here, and it comes all the way down here to the bottom, then we're going to return whatever the value of I is. Now, all we have left to do for our current conditions is to actually display the current conditions. We've created all the elements, we have translated the icons, everything is ready to go, and we've got that array of elements created. So way back up here in our update display function, after we've created this array, the very next thing to do is to call the display current conditions function and pass in that CC array, which is the current conditions array. So let's take this and go to the bottom and we'll define it, and then we'll be able to look at our app and actually see the changes. Scrolling back down past all the longer functions, especially when it has a switch statement or something similar. Okay, here we go. Const display current conditions, and this will receive a current conditions array, or what we called CC array above, but I wanted to spell it out here so it makes sense. The code should document itself when possible. Now within here I'll say const CC container, because we've already spelled out it's going to be current conditions. And now we'll set that equal to document.get element by ID. And we're going to get the current forecast 2 underscores conditions div. After that, we'll say the current conditions array that is passed in, and then we'll call for each on that array. And for every current condition, we'll call this function, and this will be on the CC container that we defined. We will append child the current condition, which is one of the elements of the array. And those are all of the elements we created. And so that should populate our current conditions area. Now let's go look at Chrome and see if we have any errors. And we did not take update display and import it. So that's twice I've got caught with that bug. We'll come back up here and grab our update display function. And after defining it, we still need to import it in the main.js file. And that comes from the DOM functions. And so let's just put it right here at the bottom. It's the very last function to get called there. And now that we've updated and imported, let's go back to Chrome one more time. And it already loaded our current conditions by default, as it's supposed to when load weather is called in the init app function. Giving this a quick look, I don't like the look of what we have up here where it has the latitude and longitude. Notice how the latitude number isn't a smaller number. It's got all the decimals, and all the decimals are here. That's really crowded in, and an even smaller phone, it might push down to another line even and take up more room. And we don't want that. So let's fix that function that displays the latitude and longitude. Okay, jumping back to our DOM functions file. If you remember, we have a function named update weather location header. And right now it's a very simple function. I'll find it here. Update weather location header is right here. But we can make this a little more complex just to display the latitude and longitude in a little more digestible form. So we'll start out with an if statement, and we'll say if, and this message that was passed in as the parameter above. And then we'll use the index of method to see if lat is in there, and that's what we saw back in our display. And then if it's not equal to -1, which means if it does exist, if the index of method does find it, and we'll do the same thing to look for the longitude, and it was displayed like this, the word long. And so now we'll have a not equal to again and -1. So it doesn't find the latitude or longitude, or actually it does find if it's not equal to a -1. If it was equal to a -1, that means it would not have found it. But if it's not equal to a -1, it does exist. And we'll put our current H1 text content assignment in the else here. So now if latitude and longitude is there, and the reason we're looking for that is because it could be a city name or a country name, and that wouldn't be displaying latitude or longitude. So we'll only format this if latitude and longitude do exist inside the message that's passed in as a parameter. Okay, now we've confirmed they exist, and so what will we do with that? Let's first define a message array, and we'll call the split method, and we're going to split it on any spaces inside the message that we received as a parameter. And that split method creates an array. So now we have a message array. Now we'll define a map array, and that's going to be the message array calling the higher order function map, which creates a new array. And this will take every element, or every message as far as how this is defined, but every element of the array, and we will do something to it that creates this new array. So in this part, we will return message.replace, and we'll replace the colon that comes after the lat and long, and we'll replace it with a colon and a space. So that will format it a little bit, and it'll look a little bit better and not quite so crowded, but it was still way too long. If you remember, the latitude and longitude were like 5 or 6 decimals longer after the decimal point. And we need to shorten that up a little bit for the display. So here, let's define lat and have that equal to the map array we just created, and it will be the first in there. So map array 0 dot index of, and now we'll look for the minus symbol. And if that equals a -1, meaning it does not exist, and we'll use a ternary statement. We'll say map array 0.slice, and now we'll start at 0 and we'll go for 10. But, oh, let's not put a semicolon there, let's put a colon. Now this is false, so if minus is in there, we need to give it one extra character. So then we'll say map array and 0 again, because this is still the latitude, and now dot slice, and we will look at 0 to 11 characters. Let's save that much. Now we're going to do something very similar for longitude. So let's go ahead and just copy this. Again, prettier formatted this up here for me, and it will this too when we finish, so I'm just going to leave it here for now. And I'll define lon, not long, but lon, and the zeros need to become ones. Well, not all the zeros, but that's what's going to happen. I need to change these two back. This is still a 0. This is still a 0. But now we're working with the longitude, so it's the second element in the map array. And the slice is going to be 0, 11, or 0, 12. So that will determine how much latitude and longitude. And again, longitude is one longer on each one because longitude is written out as L-O-N-G and not just L-O-N. So latitude and longitude aren't the same length as far as when we're looking at characters. So now we've determined the lat and the lon. I'll go ahead and save this, and yes, it formatted back to where it should be. And this should display much more, a much more easy to read message in the header for lat and longitude. Now the only thing we haven't done yet is set the h1 here. So we did below in the else. So let's have our h1.text content and set that equal to a template literal, and we'll pass in lat, and then let's go ahead and use a special character, and I'm going to use a bullet. Again, you can find a bullet on a Unicode site, or you could possibly know the correct key combination to just pull it up on your keyboard. And there is the lat and longitude, and that's what will be assigned to the h1 after it's formatted through this function. So let's go back and take a look once again. And look, our latitude and longitude, much easier to read now when we look at this than the crowded mess we had up here before. And our current conditions are now complete. Okay, let's complete our function now by displaying the 6-day forecast. Remember, we have the update display function. So right here, the very last function to call inside is display 6-day forecast, and this will receive the weather JSON that we have, and that completes the update display function. So now we just need to define this display 6-day forecast, and we will have completed the DOM functions. So let's scroll to the bottom, and here we can define this function, display 6-day forecast. It'll accept the weather JSON parameter. It's an arrow function. And we're going to have a for loop here. So we'll say for, and then let I equal 1. And then while I is less than or equal to 6, because we want the 6-day forecast, then we'll increment I. And in this basic for loop, we'll define a df array, and that daily forecast array, and here we'll call the create daily forecast divs function, and we'll pass in weather JSON dot daily, and now we'll pass in I from the for loop as the day that we need. So we'll go from 1 to 6. 0 was called in the current weather conditions. So now we're getting the future weather conditions for the next 6 days. And as the for loop increments, it will get the next day and the next day and so on. So after it gets that daily forecast array of information, then we'll call the display daily forecast function. We'll pass in that df array. And remember, each day of the week will have its own array of information that we're grabbing. And so that's why that's called df array. And this display daily forecast will be called for each day of the 6 days. Okay, we'll save this function. And so now we clearly need to create daily forecast divs, and we'll need the display daily forecast function. So right underneath, let's start with create the daily forecast divs, and we're going to pass in what we will call day weather, and that is equal to this weather JSON.daily and whatever number of the day it is. And this is an arrow function as well. So here I'm going to define a day abbreviation text, and I'll have a helper function called get day abbreviation, and pass in day weather, which was our parameter, .dt. And after that, and we will come back and create that get day abbreviation, we'll define our day abbreviation, just day abbreviation, not day abbreviation text, as create elem, which is that helper function we've already created. It will be a paragraph element. We'll have the day abbreviation class, and it will have the day abbreviation text that we defined. From there, we'll define a day icon, and we're going to set this equal to another helper function. So let me hold off on this create day or day icon at first, and let's go ahead and create this get day abbreviation underneath. So there we'll have const get day abbreviation, and we'll pass in data. I need an equal sign first. Pass in data. And now we'll get the date object. We'll call this new date. So we are creating a date object, and we'll have the data that we've received times 1000. So this is data we're getting from the API, and we need to take it times 1000 to get an accurate date created here. And then we'll define a UTC string. We're going to set this equal to the date object dot toUTC string method, which is built into JavaScript. And then we'll return the UTC string, but we'll slice because it will be much larger than what we want. We just want the day abbreviation. We'll just slice from 0, and we'll stop before the 3. So 0, 1, 2, 3 characters total, and then we'll put it to uppercase. And so this would give us our standard abbreviations of sat, sun, mon, so on for the days. And now that we've returned that, we've completed that function, we'll go ahead and save. And Prettier broke this down for us as well. Let's go ahead and complete this create daily forecast divs. So the next thing we'll add is day icon, and have that equal to create daily forecast icon, which is another helper function. And here we'll pass in day weather. We need this to be capitalized. Day weather, there it is. Dot weather, bracket for 0, dot icon, and then also day weather, dot weather, bracket for 0 again, dot description. And after that, we will create the daily high, and that is with the create elem helper function. It's a paragraph, and the class will be day high. And then we'll use a template literal called math.round, pass in a number object, and then day weather.temp dot max. I'm sorry, not number object, number function is what I meant to say there. And once again, this will have that degree symbol. We'll put it right before the closing template literal backtick there. And we can save that. And if I'm remembering correctly, we did not do the create daily forecast icon function yet. So let's go ahead and make that function. It's not too long either. Right under the get day abbreviation. So const, oh, I didn't copy it. Create daily forecast icon. There it is. And it receives the icon and alt text for the icon. And now the first string will define an image. This will be document.create element, and it will be an image element. And now we're going to use another if statement, but we're going to check what I previously called a JavaScript media query. Again, we're going to check the width of the page, and we're going to make our decision on the size of icon that we request from the API, because the Open Weather Map API provides more than one size of icon. So here we'll say if window.inner width is less than 768 pixels, or window.inner height is less than 1025 pixels, then I'm going to paste this URL in just to shorten things up, but then we'll set the image source attribute equal to, and this will be a template literal, the openweathermap.org/image/wn/ and then you put the icon ID and then .png. But there's also an else to this if statement. And so if it does not meet these less than qualifications, we're going to set the image source to something slightly different. So I'll paste in the original URL here, but what you want after the icon is to say at 2x, so a larger icon. And then after the if statement is finished, we'll set the alt attribute to the alt text we passed in, and then we'll return the image. Let's scroll back up and finish this function. There's not much to go. We've got the day icon, the day high. Let's now define the day low and set that equal to create elem as well. Another paragraph. Day low is the class. And now another template literal. And it will be, let's see, a curly brace and math.round. Pass in the number function and say day weather dot temp dot min, and we again need this symbol. Put it right before the template literal closes, and we can save that. Now after the day low, we once again just need to create, or actually return, an array with all of these elements. So we have day abbreviation, day icon, day high, and day low. And that's what each of the extended forecast days have. So we return that. And that is our daily forecast array. So if we come back up here to where we want to display the 6-day forecast, we've now created the daily forecast array, and we have the elements within it. So we need to define the display daily forecast function. Let's copy this, and we will scroll to the bottom and define our last function here. Const display daily forecast, it equals this, it receives a daily forecast array. There we go. And now we're going to define a day div, and that's going to equal a create elem, and it will have a div, and the class will be forecast day, and we'll just leave it at that. And then the df array that is passed in as the parameter will go for each, and we'll just say for each element, and we will call day div dot append child, and we'll pass in the element. After that, let's go ahead and define a daily forecast container. Set that equal to document.get element by ID, and this will be the daily forecast 2_ contents that we previously defined. And then we'll say daily forecast container dot append child and pass in the day div. And now we should be able to see the daily forecast at the bottom of our page in the div that we had previously defined to hold that dynamic content. So let's go back to Chrome and see how it looks. And now we have our daily forecast, or our advanced forecast for the week, or whatever you would like to call that. Now that we've completed the functionality of the app, let's go ahead and expand the window, and we can look at it this way, or we could look at a smaller version. Remember that we'll hide some of the things that we're displaying, so we no longer see a couple of the pieces of information here. We have to reload for the JavaScript media query to kick in. So right now this is too long, but if we reload, it will just say city, state, country. Likewise, if we go back up to a larger font size, we get this, but again, the JavaScript doesn't kick in. That's the same for the size of the icons here. So these are the smaller icons. Once we get to a larger, say like a tablet, we'll have to reload and we'll get larger icons here. Because JavaScript is making those decisions when the functions run, and it's not the same as a CSS media query where you can drag or just change it in DevTools and have it change instantly. But it does work. So that's good. Icons are too big now, so let's go ahead and reload and it will size correctly. And that's what we expect. So let's check a few places around the world. Right now we're using the latitude and longitude of San Francisco. Let's go to Seattle. Yes, and our images are changing as we wanted. It's rainy in Seattle right now. Let's go to Taiwan. And it's misting in Taiwan. Everything is again working like we expect it to. Let's look at somewhere else, maybe Moscow. A little bit of snow in Moscow right now, that's good. And where could it be nighttime? Maybe Cape Town, South Africa right now. And it's nighttime in Cape Town. And remember, we're changing the color too. So this is kind of that ruby color blended in with the nighttime image. And you can change those to your preference as you would like to. And let's check close to my home, somewhere near Kansas City. And it says it's nighttime here as well. So let's go somewhere where it's daytime again, like maybe Tokyo. Daytime in Tokyo. And everything's working like we want it to. So what we have left to do is to change our functions to serverless functions that will hide our API key, because right now the API key is completely visible in our code, and we don't have to protect the open weather API key too much, but it is a good practice to protect API keys, and somebody could even use your open weather key too much and it would get turned off. We now have a functioning app, but what we need to do yet is create a couple of serverless functions, and that will give us the ability to hide our API key in those functions instead of keeping them in our front end code that would be in the browser where anybody could see it. And also we'll keep those, we'll keep our API key out of our GitHub repository. And that is important because if you're going to lose it anywhere, it's probably not in your code. It is probably going to be from somebody sniffing the code or scraping the code from GitHub. So you don't want your API keys in there. Before we start that, just a couple of quick cleanup mentions. We can see on main.js line 157, we have a console log statement. Also on datafunctions.js on line 39. So let's clean those up. Again, data functions 39, main.js 157. So let's go to data functions and 39, and there's that console log statement we can now remove as we have everything working. save that one, and main.js 157. And there it is. We'll go ahead and remove that console log statement as well. Now that we've done that, the very first thing we need to do is create a netlify.toml file. That's a .toml. And we will host this application on Netlify. Netlify makes creating serverless functions through Amazon Lambda very easy. So in the root area, not in the JS folder, but just in the root, the same place that, not in the dist even, but here in the root, I guess, not the same place as the index or anything else, just right here. Let's create that netlify.toml file. And we're only going to indicate a couple of things in this file. And the first one we'll put right now is build, and we're telling Netlify where our build folder or directory will be. So we put publish, and it's going to equal dist /. And we can save the file for now. Later we'll also tell Netlify where to find our serverless functions. But this is really all we need right now. And now we want to create a Git repository and go to GitHub. Here we go. And so we're going to use git init. Now, if you haven't installed Git before or used GitHub, I have a tutorial on that, and I'll link to that above right now. But once you have Git installed, you can initialize a repository by typing git init. And now we've initialized our repository, and you can see everything over here in the file tree turned green as it considers them to be new files. We can type git status, and it will list all of those. And of course, it also includes the files in there. And now I'm going to type git add and dot, which means add all. And that's good. Now, one thing we've done already, now we haven't pushed this to GitHub, but one thing we've done is include that API key. Now we can, if you accidentally send your API key to GitHub, you can go into the Open Weather Map site and just delete that one and create another one easily enough in your account. But right now we have this in our code. So that is a consideration as well. So what I'm going to do, and it will break our app, but what I'm going to do is remove this and save. And then we'll check the git status again. And you can see now it just indicates the one modified file. Everything else has already been added. So now we'll add. And now we'll make a commit, git commit -m, and we'll just call it first commit. There we go. And now I would push to GitHub if we had already linked this to a repository, but we haven't. So we need to go to our browser. And on our browser, of course we broke the app now. Let's go to GitHub, and you want to go to your repositories page. If you don't have a GitHub account, sign up for one, but you can click on your icon in the top right and go to repositories. And after you do that, click on new on the repositories page. And I'm just going to call this weather_app_tut. There we go. And we don't need to create anything else, no README, any of this stuff here. We can do that later on our own. Let's just click create repository at the bottom. And once we've done that, we can git remote, add origin. This first line, I just copy it and I click in the terminal. Let me find the terminal over here. And I right click and it just pastes it right in. Okay, after that, let's go back. You can see then you type git branch -m main. So you're essentially renaming the branch to main, which is the new standard instead of master. And then we git push -u origin main. So we can type those in. Git branch -m main, and then git push -u origin main, and this will push your code, your repository you've created, to GitHub. And that takes a second, but now it's complete, and we can go to our repository on GitHub. and click the repository up here at the top after your username, and you should see your code in here. With that complete, now we need to go to nodejs.org, and from there you need to install Node if you don't have it, and just get the recommended version. Here I'm on Windows, you can see, or it will recommend whatever operating system you're on, or there's the other downloads link. But download the recommended version of Node, and it will also install NPM, which is Node Package Manager, and that is what we need to use right now. So if you haven't installed that, go ahead and pause and install Node, and then come back and we'll start working with Node Package Manager. Okay, with NPM now installed, let's go back to Visual Studio Code, and we're going to initialize NPM. We'll type npm init and then -y, which will prevent it from asking us several questions as this starts. And this will create a package JSON file in our project as well. And you can see that over here on the left now. Let's go ahead and pull the terminal window down a little bit and click on our package JSON. And you can see it just has weather app tut as the name, version 1.0.0. And really some generic things here. Nothing we need to be concerned about for this project right now, because we don't really even have a build command for this. It's just a standard project. However, we are going to install a dependency. And how we do that with npm, so type npm and then I for install. And the package we want is node-fetch, because Node.js does not have the fetch API built into it like Vanilla Javascript does. So we'll go ahead and press enter, and that package will install. And now we can see in our package.json that the node fetch dependency is now part of our project. And now that we've initialized Node, you also notice we have a Node modules folder, and this can have many libraries inside of it, or packages inside of it. So what we want to do there is not include that in our GitHub repository. Let's go ahead and create one new file right here in the root again, and this will be a .gitignore file. And inside this gitignore file, we want to include node modules, and then we can save. And now you'll notice it's grayed out, and it will not include the node modules in our GitHub repository, or our Git repository for that matter. Now we need to go back to our netlify.toml file, and we're going to come down a couple of lines and tell Netlify where to find our serverless functions. And we'll do that with functions equals, and I'm going to create a folder called serverless, and that's where our serverless functions will be. So we'll just save that file like this, and we're finished with the toml file. And now once again in the root, not in the distribution folder, but in the root, we'll create a serverless folder. And this is where we will save our serverless functions to load up to Netlify. So we have serverless code to write, but we also need to change our functions in the data functions.js file. And we'll start by changing our getWeatherFromChords function that we have right here. But instead of deleting this code, let's just comment it out and we can look at the differences. Or we could even just use some of this code and alter it. So maybe we'll do that. I'll start down here and then we'll end up commenting out this code. But what we want to do is pass a URL object to our serverless function. So we'll define this URL data object, and we'll have it equal an object that has pretty much what we're doing right here. So let's just copy this, and we're pulling the location object in as a parameter, and I'll paste this in. But clearly we don't want to define variables in an object, so we'll grab all three of those const and get rid of those, and we'll grab all three of these equals and we'll turn those into colons. And so now we have location object.getLat, and these three semicolons need to be commas, except for the last one that doesn't need to be there at all. So now we've created a URL data object with lat, lon, and units. And that's what we need to pass in to the function. So from here, we'll start a new try block, and we'll define a weather stream once again but it will be just a little bit different than we had up here. I'm going to copy and paste that. And our fetch will have a URL that we define here, and it's a specific URL to find those netlify functions. So it's // and then .netlify/functions/ and we're going to name our function get_weather. And then we need to pass in a couple of parameters for fetch, and we do that with an object. So now that we're ready to pass in these parameters, the first method, or the first one is method, and it is post. So we're not sending a get request anymore, we're sending a post request. And then we need to pass in the body of this post request, and this will have the URL data object. We'll use json.stringify and pass in that data object. And we'll save that, and our fetch is now complete. We'll follow that with the exact same line we had here before, and that is getting the JSON in return from the weather stream. And actually after that there is no difference in this function, so we can just copy these other lines and we can return the JSON that we get back from the serverless function, and we'll have a catch block here for the error if it does occur. Now let's go ahead and comment out our other code so we don't have an error by mistake. So we'll just comment this out to save our code that does function without the serverless function. And looking down here, yeah, we've got one too many curly braces closing it out. So now we've saved it, and this will submit to our netlify serverless function get_weather. And we'll just keep this code here if you want to refer to it, the code that works without a serverless function. So now we're ready to create our first serverless function getWeather. And we'll do that by highlighting the serverless folder over here in our file tree, and we'll create a new file, and we'll call it get_weather.js. And now in this file, we're going to start by defining fetch, and here we will require that dependency we installed of node-fetch. And now we need to define the weather API key. And we'll be pulling this in from Netlify using their environment variables. Usually when you're working with Node and you're pulling in an environment variable, you need to install the dependency .env, but you don't have to do that with Netlify and serverless functions. But Netlify will still be able to provide that API key when we put it in our dashboard in Netlify. So here we're defining the weather API key, and it will pull it in from the environment variable when we give that to Netlify in the dashboard. So now that we've defined our fetch and our API key, we can go ahead and create the function. And the serverless function starts with exports.handler, and that equals async. Here's the event, and it also receives context, and it's an arrow function. And we'll start out by defining params, and here we're going to receive that JSON, so we call JSON parse. This is event.body, and that is what we sent in with our request in fetch. So we can deconstruct the params now. It's an object, so we will do that, and we'll define lat, lon, and units from that object. So we pull all of those out of params by deconstructing that object. And then we'll define a URL. And now we need the URL that we were pulling in, or we were submitting to directly from our front end code. So I'm just going to copy and paste it once again. It is a template literal. So start and end with the backticks. And in between, I'm going to press Alt-Z to get this code to wrap. In between, we insert in our variables. So we have our lat, lon, units, and our weather API key that gets inserted here as we make the request to the OpenWeatherMap API. Now that we've defined our lat, lon, units, and our URL along with our API key, we can start our try catch block. And now this will look very familiar to what we had in the front end code. So I'll define weather stream. That's going to equal await fetch URL. Then I'll define weather JSON, and that's going to equal await weatherstream.json, or the JSON method. And now the return is just a little different. In return, we're going to pass in an object here, or return an object, and it will have a status code of 200. That's what Netlify suggests for a successful return, and that is a HTTP code. And then the body, this will be json.stringify once again, and now we'll pass in the weather JSON. And that's the end of our try, but now we still need to specify the catch block. So now we can type catch error, but here we don't want to log to the console. We couldn't see the console of the serverless function anyway. It's not with our code, it's on the server and running an Amazon Lambda or AWS Lambda function. So what we need to do is return something here as well. And we'll return another object, and here we'll say status code 422, which I believe is unprocessable or something like that. And then body error.stack. And that'll just send the full error stack back to us, and then we can receive it and process that error stack in our front end code. So let's save that much, and we have completed this first serverless function. So what you can see is that it receives an object from our front end code, then it makes the request for us because the API key will be saved in our Netlify account, and the environment variable will pull that in. It'll make the request, and it will send back the weather JSON that it receives. So in essence, this function is a relay, and it's similar to a node relay that I created in another tutorial, and it makes the request for us, and it sends the data back to us. Okay, now that we've completed this one, we have one more to alter in data functions. We'll scroll down, and it is the get chords from API function. And we'll do the same thing here. I'll just space down and we'll start the new code, and then eventually we'll comment out the old code of the function so it can still remain in the repository and you can see the code that worked directly from the front end code, and then we'll have the code that sends to the serverless function as well. So here we're also going to define a data object to send to the serverless function, and it will have text, and that will be the entry text parameter that the function here receives. And it will have units, and that's the other parameter the function receives. So now we've defined our data object, semicolon there, and then we'll start our try block. Inside the try block, I'm going to define a data stream. This is going to be equal to await fetch, and now once again we need that specific address to go to the Netlify function. It starts with // then .netlify/functions/get_chords, and that is the name of the serverless function we're about to create. Now we put in the object again, and we'll say method, and this will be a post request, and then the body gets passed to the serverless function, and we'll use json.stringify, and we'll pass in the URL data object. Okay, we've completed the fetch. Now we'll define JSON data, and that's going to be equal to await datastream.json, and then we'll return the JSON data we received back from the serverless function. And now the catch block is going to be fairly simple here. We'll just catch the error and console error the error. There we go. And I can't remember if I said error or log up here. No, we did error as well. There we go. So that's good. And that's the end of the function that we've altered here. So if we compare all of this is going to be happening really in the serverless function. So let's take this code and comment this out. And now we know we need to create a get chords function. So back in the serverless, let's click new file, get underscore chords.js. This get chords function starts out the same as our previous function, so I'm going to go to the get weather function and quickly copy these first 3 lines and go back to get chords. And now we're ready to add the rest of the get chords function here. We still have to require fetch, and we've pulled in our API key. So now once again we receive params, and we'll have those equal to JSON parse and event.body. From there we're going to deconstruct those params, and we'll get text and units from params. And now I'm going to define the regex, and this equals slash, and then starts with D and ends, so that's looking for that number. Once again, this is the same regex we had before. And here I'll define the flag, and this is going to be a regex test, not text, and we pass in text. There we go. And it is the same ternary statement we had before. It's either zip or Q for query when it's finished. And then we have URL, and this URL will be a template literal. I'm once again going to copy and paste here. Here we go. We paste that in. I'm going to press Alt-Z to wrap so we can see it. And this is placing the flag variable in, the text, the units, and the API key. And right now this is very similar except where we got the params. So starting here with the regex, very similar to what we had in our front end code, if not identically the same. And now we need to encode the URL also. So we'll define encoded URL, set that equal to encode URI, which is built into JavaScript, and pass in the URL. And now we can start our try catch block. Here we'll define the data stream, set that equal to await fetch, and this will be the encoded URL that we pass in. Then we'll define the JSON data, have that be equal to await data stream, and call the JSON method. And then we're going to return, and this return will look much like the last function where we have the status code of 200, and then the body, we'll call the JSON.stringify method, and we'll pass in the JSON data. And then we need to jump down to our catch block. And this will actually be identical to what we had in the previous function. We'll just return an object with the status code of 422, and the body will be the error dot stack. And now we've completed our get chords function as well. So if we look back at it, it receives the object, breaks it down, and makes the request for us. These things are things we were doing in the front end code before. And then after it gets that JSON data, it just sends it to our front end from this serverless function. And serverless function is kind of a paradox because this is running on a server. It just, by serverless, they mean we don't have to manage the server. So it's sending us the code back, and essentially, once again, a node relay when we access this API. And we can check our status, see what all needs to be sent or committed or added. And yes, we've got a few new things here, so let's go ahead and add all of that. Git commit -m, we'll say added serverless functions. And then git push to our repository. And once it's pushed to GitHub, we can go to netlify.com. And once you get to netlify.com, sign up for a free account. If you already have one, you should go directly to your team overview, your dashboard, and you can choose New Site from Git, either once you have signed up for your free account or once you've just opened your existing account. And I'll choose New Site from Git, and here's Continuous Deployment, and I'm going to choose GitHub. And now I'm going to search for weather. And I'm going to choose the weather app tut repository that we have on GitHub. The main branch to deploy, that's fine. You can see it already knows my published directory is dist that we showed in our netlify.toml file. And then I want to click Show Advanced. And in the Show Advanced, you can add an environment variable right away. So I'm going to click New Variable, and here I'll put weather underscore API underscore key. And I'm going to paste in that weather API key that I got from the Open Weather Map site. And now I'll click Deploy Site. And it says Site Deploy in Progress. And then we can check the deploys to see if it's building or if it's actually deployed. But we're not interested in going to our URL yet. And if we go back to the site overview, once it's deployed, we should see a URL pop up for our project. And with our project deployed, you can now see the netlify.app URL we're given for our project. And you can even get a little snapshot over here. But we're not interested in going to this URL yet. We want to set up our dev environment and check our Netlify serverless functions in our local environment first. And to do that, we need to get a command for npm to install the Netlify CLI, that is the Netlify command line interface. So I'll go to the docs.netlify.com, and then there's /CLI/get-started. And it talks about the Netlify CLI, but what we really need is this command, npm install netlify-CLI with the global flag. So let's go back to Visual Studio Code. And in Visual Studio Code, looks like I need to open up a terminal window again. We would need to type npm, lowercase, npm I for install, and then netlify-CLI-G is the global flag. Now I already have this installed, but if you do that and press enter, then you will install Netlify CLI through npm. Okay, after installing the Netlify CLI, we need to link our project, and you should be able to type netlify link. And now you're given some choices, and the easiest choice is use current Git remote origin to link your project. And so just press enter, and now your project from Netlify is linked to your local dev environment, and you can type netlify dev to launch your project. And there our project is launched on localhost 8888, and it is using the serverless functions in our local dev environment. Let's go ahead and look at a mobile phone view as well. And it's looking good. So if we go back to Visual Studio Code, let's take a quick look at what we saw in the terminal. And after we launched our netlify dev command, netlify dev started, it injected the build settings. That environment variable key that we stored at Netlify is pulled into this local dev environment using netlify dev. And then it has a few other messages, and it says our server for the functions is listening at this port, and another server is listening at this port, but the server is now ready on localhost port 8888, and that's where we view our dev site now when we use netlify dev. A quick debugging note, if you are seeing an error instead of your app working that says type error, failed to resolve module specifier node-fetch, that means an import statement was automatically added to the top of your data functions.js file. It happened to me also, so you will want to remove that import statement at the top of the data functions file and once again push your code to Git, which will then automatically deploy it through Netlify. And now that we've confirmed everything is working in our local environment, let's go back to the browser and let's go back to Netlify and let's click our .app URL for our live site and let's see if it's working as well. And we need to click allow for our location. That's why we're not seeing data yet. This is the first thing the app will ask because it wants to get the geo coordinates. So click allow. And our app is functioning and live on the web. Now let's test out some accessibility functions for the app. And we'll start that by getting the Chromevox screen reader. You can go to the Chrome Web Store at chrome.google.com/webstore and then search for Chromevox. The screen reader is the first thing that comes up. And then after you do that, you want to install it and go to the three dots and then more tools and then extensions. And you can launch the extensions. And after you have the screen reader installed, you can activate it right here.
Chromevox spoken feedback is ready. Responsive weather app, tab.
And this is our local version.
Responsive weather app, tab.
Here is the .app version. Either one works to test out on, so we'll just stick with the .app version. Let's test a location.
Search. Enter a new location within city, state, country, or zip code. Edit text.
I like how
Enter a new location within city, state, country, or zip code. Edit text.
I like how it reads the directions to us. I'm not sure why it read it twice.
Wichita.
Wichita, press
Return.
enter.
Enter zip code or city, state, and country to retrieve weather conditions. Button.
Okay, now there's a couple things there that didn't go as planned. One is after I pressed enter, it put the focus directly on this button, which is okay, but we gave directions about how to enter there, so we don't want that to read after we enter in that location. So I want to change the ARIA label for this button and maybe just change it to submit search because that describes the button. After that, the assertive statement, the alert or confirmation that we want the screen reader to read also didn't happen. So let's go back to Visual Studio Code and make a couple of quick corrections and then we could deploy those changes. We're in the index.html. And here we can change the ARIA label for the button and I'll select all of this and instead of saying all of those things, especially after a search is entered, we'll just describe the button if it gets the focus and it's a submit search button. So we'll say submit search and it will announce the button element afterwards already. We can save that. Now let's go ahead and look at the DOM functions and something about this screen reader or update screen reader confirmation isn't reading correctly. And if I analyze this function, I can see I didn't spell text content correctly there. I left an N out and that's why that is not happening. It really doesn't throw an error, it just doesn't happen. So sometimes those are hard to catch, but we knew specifically what we were looking for because we broke this application into specific functions and we knew this wasn't working. So now that we've made those changes, we can go back and probably need to reload or relaunch our code here. So let's try to reload.
Window responsive weather app tab.
We were using
Enter a new location. Wichita.
The .app.
Edit text. Alert. Alert.
So in this version, we would actually need to push the code back to GitHub and have it deploy over to Netlify, but we can go to our local version before we do that.
Tab.
I'll change the view back to DevTools. And let's reload this.
Responsive weather app. Section search. Enter a new location within city, state, country, or zip code. Edit text. W. Wichita. Return. Submit search. Button. Clear sky and 57 degrees Fahrenheit in Wichita, US.
Now that's what we wanted. It said submit search button, and that's what was highlighted. That's fine. And then it read the weather to us. So let's try a little bit more. Let's go.
Shanghai. Return. Submit search. Button. Clear sky and 48 degrees Fahrenheit in Shanghai, CN. SM. Moscow. Return. Submit search. Button. Scattered clouds and 18 degrees Fahrenheit in Moscow, are you? Moscow. M. Space. New Delhi. Return. Submit search. Button. Mist and 77 degrees Fahrenheit in New Delhi in. New Delhi. N.
Okay, let's try one more.
Ice. Iceland. Return. Submit search. Button. Snow and 32 degrees Fahrenheit in Iceland, IS.
Nice, so that all works as expected. Now let's tab through the app.
Submit search. Exited section search. Skip to current conditions.
There's our skip
Internal
link to the current conditions. And if this app was rearranged where the navigation was on top, this would be even more important because you want to be able to skip through the navigation. Let's go ahead and tab past this.
Skip to 6-day forecast.
And now we can
Internal
skip
link.
directly to the 6-day forecast without going to the navigation. So let's try that.
6-day forecast region. 6-day forecast. Heading 2.
And so now with Chrome Vox, I'm using Windows, so I press the Shift Alt and the arrow down key to go to the next item that I want it to read that's not necessarily a tabbable item. So I believe if you have a Chromebook, it's Shift and the search key, and instead in Windows, it's the Alt key. I'm not sure about Mac and Linux. So Shift Alt down.
Tuesday. Light snow. 22 degrees. 14 degrees. Wet. Snow. 20 degrees. 13 degrees. Thursday. Light snow.
Nice. Everything's pretty much working as expected. I'm going to press Shift Tab to go backwards. Well, I believe because I'm in DevTools, that didn't work as expected there. Let me press Shift, Alt, and then I can press NH. Well, I think I'm tabbed off the page entirely. Wait.
Enter a new location. Iceland. Edit text.
Now let's try Shift, Alt, NH.
Iceland, IS region. Iceland, IS. Heading 2.
Went to the next header. That's what NH stands for. Now I'll do it again.
6-day forecast region. 6-day forecast. Heading 2.
Now if I do Shift Alt PH, I go to previous headers.
Iceland, IS region. Iceland, IS. Heading 2. Responsive weather app powered by the Open Weather API. Heading 1.
And there was our heading 1 for the page. So everything is working as we wanted it to. The only thing we haven't done is go to the
Enter a new
nav
location. Iceland. Edit text.
and read through the current conditions. So let's do that.
Submit search. Exited section search. Skip to current conditions. Iceland, IS region. Iceland, IS.
Now I'll press
Heading
Shift,
2.
Alt, and the down arrow.
32 degrees. Snow. Feels like 22 degrees. High 33 degrees. Low 18 degrees. Humidity 99%. Wind 11 miles per hour. Skip to 6-day forecast.
And
Internal link.
I'll bypass this.
Navigation. Get the current weather conditions for your current location. Button. Get the current weather conditions for your home location. Button. Save the current location as your home location. Button. Toggle between metric and imperial measurement units. Button. Refresh the current weather conditions. Button.
That's great. Everything seems to be working as expected there. Now I'll just click the home button.
Navigation. Section search. Enter a new location. Iceland. Edit text. Clear sky and 59 degrees Fahrenheit in Kansas City, US.
Okay, I'm noticing one thing I want to debug. Okay, I've disabled Chrome Vox and we're back in the DOM functions. What I wanted to debug was I was not seeing the little F for Fahrenheit or C for Celsius. And as I got back into the create current condition divs function, I noticed we defined temp unit, but we hadn't used it. And we should have put that in the temp when we create the temp element. And after it is created, we want to put a comma right here and then include temp unit yet, which we missed doing. And after that, we should have our F for Fahrenheit or C for Celsius. Let's go back to our local hosted site and we'll get rid of Iceland here and let's just refresh the page. There we go. We now have the F for Fahrenheit, and if we click the button to change the units, we now get a C for Celsius, and all the units change as well, which is fine, but we were just missing this little letter here by the large temperature, and I wanted to make sure we got that in there as well. Okay, now with these final changes, one more time back to Visual Studio Code. Just because we have it working with the local Netlify dev doesn't mean that we have pushed it to the live Netlify site yet. So press Control-C in your terminal to stop the Netlify dev localhost, and then we'll type git, we'll add all of our changes, and then we'll type git commit, and I'm going to type fixed, let's call it units bug, or typo in that instance. The typo caused the bug, and then we'll have git push. I was thinking I didn't add for a second, but that's what we did first. We add, commit, and push. It goes to GitHub and will deploy automatically to Netlify. The app is live and functioning as expected. So what can be improved upon? Well, I'm sure I'll see some things I would like to refactor the next time I revisit this project, but here are the things that I know right now. The background images take time to load the first time they're pulled up. After the first time, they load from the cache much faster. Now, there's several ways to handle this, but what I would like to do is make this a progressive web app. With the PWA, the service worker could load the images in the background. Also, a PWA would launch from the mobile desktop, and that would be like a native app on a phone, which would be nice for a weather application. With 4 clearly defined components, this application is ripe for a refactor with React. So if you're wanting to work with React going forward, this would be a good project. The reverse lookup by the Open Weather API leaves something to be desired. A search for Manhattan, Kansas still delivers the weather for Manhattan, New York. You have to specifically state Manhattan, Kansas, US to get the weather for the correct location. So in the future, a different reverse lookup endpoint may be desired. I also think my SCSS could probably be a bit drier and more efficient as well. Let me know what you think in the comments below, and if you refactor the project, please share a link with me. Until then, the videos on the left may help you on your coding journey. Thank you so much for watching and subscribing. I appreciate the support, and I'll see you next time.